Hello everyone, welcome to IS Baba. This is a very important series, that is the rapid revision series, wherein I'm going to teach you geography and some very important fundamentals of geography that is very important from this year's perspective. Now student, before going with the topic, let us do a 2-minute analysis of the strategy that we are going to formulate. And this strategy should always be formulated on the basis of the previous year's trend. So if you look into the geography question paper of last few years, you will see that in last couple of years, especially in last 4 years, if you can see, the number of questions, especially with prelims, have been increasing. So it's 10, 12, 19 and 20, and this includes the mapping questions also. Okay, so geography conceptual questions, if we see, that would be like 7 to like 10, not more, but like rest of the questions are mapping based, and these mapping based questions are current affair oriented. And I'm going to take some important current affair aspects also along with the topic. It will be covered, and mapping that is related to current affair, that should also be covered towards the end of the series. Now here, if you see the analysis of some important topics, especially the physical geography, we are going to follow this sequence, and prelims number of questions with respect to each of these topic in each of this year. You can see solar system have been asked a couple of times, and in last like 4 or 5 years, if we see the recent analysis, it was asked in 2022 and 2023. Similarly, with respect to the geomorphology, not many questions in the prelims. It is a very huge, very bulky topic, so you should not be like getting carried away in this topic, because it is important, but from the mains perspective, from the prelims perspective, not many questions are being asked. Climatology, if you can see, there are a good number of questions, and in last 5 years, almost every year they have asked questions. So here UPSC have a special focus, because climate is quite dynamic, and dynamic aspects are always there in the news, and news related things certainly would be like focused by UPSC. Oceanography, again you can see some questions there, and world biome, some questions here also. So this is the like the world geography or the fundamentals of the physical geography, and here you can expect maximum conceptual questions. When it comes to the Indian geography, here in the case of the Indian geography, you can see they have asked question on the Indian physiography, they have asked question on the geographical extent of India, that is mostly mapping related. Then drainage system, as you can see, drainage system is very important, not just one. They have at time even asked 3 questions. Climate, Indian climate, that is monsoon, and the phenomena associated with variability in monsoon like El Nino, La Nina, these are also frequently in the news. For example, in 2015 they have asked question on the Indian Ocean dipole. Okay, and so it was there in the news. El Nino is there in the news, so you can expect a question on El Nino this year. Soil related question they have asked, because soil degradation is becoming a big problem, and there are efforts for the soil conservation. On a similar line, with respect to the world biomes, we have Indian biomes also. So from world or Indian biomes, you can expect 1 question. Okay, so if you collectively do this world biomes, Indian biomes, okay, you will definitely get 1 question. Every year 1 question is there. With respect to agriculture, you can see there are many number of questions. Okay, these forms part of the economic geography. So economic geography have got some overlapping with the Indian economy. So many questions will be asked in geography, but this will be in accordance with that of the Indian economy. Also with respect to science and technology, or with respect to the environment and ecology. There are questions on minerals, as you can see in the recent years, resources and minerals. They was consistently asked good number of questions, and most of these earlier used to be factual, very fact oriented or data oriented question, but in recent year they are asking more of current affair based questions. Similarly, you can take the topic of energy. Okay, in the last 3 years they have asked only 1, but if you take the trend of last 10 years, consistently they have asked almost every year. and this again goes in accordance with that of the Indian economy, and because policy related to energy they are usually asked, and science and technology also. Energy is very, very important, especially with respect to the non-conventional energy, the renewable energy, okay, which is often in the news. Industries not very important from the prelims perspective. Mains it is important. Infrastructure, that is roadways, railways, waterway, ports, of all UPSC have mainly asked question on ports. Okay, so we shall be focusing mainly on ports and waterways. Okay, roadways and railways. Roadways, they had just asked one question last year. As such, roadways are not very preferred, and railway they haven't asked question in last 10 years. Okay, then it comes to human geography. In last 5-6 years you can see no question at all, but yes, there are questions from world mapping and India mapping, and almost every year it is seeing that around 5 to 6 questions are there in the mapping. So it is very, very important that you do this mapping from the current affair perspective. But before that, have a basic hold of the conceptual mapping, the factual mapping, or those mapping which is very obvious for a student to know. And a lot of this would be covered while we cover the conceptual topics. Okay, so let us start with the solar system. As we have seen that they have asked the questions on the solar system, so we should be focusing on the solar system. Solar system is again having overlapping with your space technology. Yes, in science and technology you have space technology, so there are questions on the solar system. So you can expect a current affair based question here. Okay, so for example, the question was asked in 2018, the question with respect to the Earth's magnetic field, it was there in the news. They had asked question on event horizon, singularity, string theory, again it was there in the news. Okay, then they have asked question on in 2023 on these important objects in the space. Okay, some are stars. Okay, some are just the giant cloud of dust and the gases in the space, and you can also expect question like you can see Goldilocks zone. They had asked question in 2015, so this year we are expecting they may ask question on Van Allen belt. Okay, so what is that? We'll see into it. There are some conceptual questions, very old questions. You may not expect question in the recent year. They are asked question on astronomical distance. Astronomical distance, the question is why it is always measured in terms of light years. So it have got some overlapping with science and technology. Astronomical distance is basically the average distance between sun and earth. Okay, I hope you know what is average distance between sun and the earth. It is you can see here in this question what is the average distance between the sun and the earth. So it was a 2007 question. Okay, and in 2022 they have asked the question is why astronomical distance is measured in light years. So astronomical distance is average distance between sun and earth, which is 150 million kilometer. Okay, 150 million kilometers. So that is an average distance. So you can see the topic is same, but the questions that is being asked, the difficulty level is increasing. Okay, the conceptual aspect, they are digging more into the depth of those topics. With respect to the rotation and revolution, they have asked question in 2022 with respect to the longest day of the year in the northern hemisphere, and a similar question was asked in 2019. Okay, wherein they had asked question with respect to again in the northern hemisphere, 21st June, where is the sun's direct ray. Okay, then when it comes to the length of the daytime and the night time in 2013, they had asked question what is the reason behind that. Okay, similarly, like some conceptual question in the previous years, concept based questions are evergreen. You must accept this fact that concept based questions are evergreen, and UPSC may ask this question in any of the year. So you should not be under the impression that these are very old questions, so UPSC will not focus. Old questions, if it is very fact based, so you may not give a lot of focus on that, but if it is concept based, so never underestimate the concept based questions. Okay, so concept based questions with respect to moon. Okay, calendar based question in 2014 they had asked, calendar based question they had also asked in 2004. Okay, so we'll do this having understood the concept. Latitude and longitude, now this is quite fact based. Okay, you need to mug up important latitudes, longitudes. Okay, and this is mapping based and through which countries they are passing. In a similar manner, a very important latitude, that is Tropic of Cancer, 23.5 degree north latitude, is passing through India, and within India through which states it is passing. But UPSC had asked question through which cities they are passing. So having done latitude with respect to country wise, when it comes to India, state wise, within the state, important cities. Okay, they had asked question related to pole stars, but more frequently they are asking question on black hole. Okay, life cycle of star. So life cycle of a star, black hole, in 2019 they had asked question, but a concept based question was also asked very long time ago. That also asked question white dwarf. So this is part of the death cycle of a star. Okay, so you see that what is the focus of the UPSC when it comes to this solar system. So accordingly, we'll deal with these important topics in a nutshell. And since this is the revision series, so here it is expected that you know something, we'll try to add up something, especially from this year's exam perspective. Okay, the current affair aspects would also be included, so that you are prepared especially for this year. Okay, so let us begin with the solar system. So as we had already discussed that this is very important topic, and every year UPSC shall be asking question on the solar system, and this have got overlapping with your science and technology, space technology also. Okay, so some important topics on which UPSC have asked question and may ask question in future again are these. Okay, so let us quickly go to the Big Bang theory. So in this Big Bang explosion, I hope you have studied this in your 11th standard NCERT. 11th standard NCERT chapter number 2, that would be sufficient for you to understand. If you're not able to understand from the 11th standard NCERT, you can go to the 6th standard NCERT and 7th standard, wherein you can read the initial chapters. So here in this Big Bang, there was these particles or the matters, all of these were condensed to a very small point, that is the point of the singularity, and from there it exploded around 13.7 billion years ago. It was very small, tiny ball. It was very small in terms of volume, very high in terms of temperature, and very high in terms of the density. And when it exploded, this huge mass of energy was later on converted into matter. Initially the expansion was quite rapid, and later on it slowed down, and the first atom was formed within 3 months, first 3 months. And with this explosion, what all was formed? The matter was formed, energy was formed, space, and even the time was created. Yes, so time is not something which is infinite. Time is also finite in nature, and 13.7 billion years. We know something from that point onwards. Beyond the 13.7 billion years ago, nobody knows. Okay, so there was a huge cloud of hydrogen gas known as a nebula that was formed. Remember this term nebula, as it was asked by UPSC. UPSC had asked recently in 2023 the prelims question related to what is this nebulae. Okay, so you can expect a question here. Okay, so nebula, it is the hydrogen gas cloud. okay, wherein the most of the stars are being formed. Okay, so in the case of sequence, you should remember the sequence also. So Big Bang explosion 13.7 billion years ago, and in our solar system the star was formed roughly 5 to 6 billion years ago. In most of the cases the stars were formed relatively during the same time, and the star formation was taken place because of the hydrogen fusion reaction, okay, which led to the release of huge amount of the energy. Subsequently, the planets were formed. The cohesion and collision of the matter led to the formation of the planetesimals. Planetesimals are basically the raw material that is needed for the formation of planet. Okay, and subsequently, in the case of the solar system, 4.6 billion years ago, all the planets, the 8 planets that we have, were formed relatively on the same relatively in the similar time. Okay, Earth have undergone changes, a lot of changes, the geomorphological changes or the climatological changes, but other planets, they have maintained the originality more of. So if we want to study more about Earth, okay, on how the Earth was previously, we go to the other planets and see how they are, because those planets haven't changed much over a period of time. So this will give us an idea with respect to how Earth was a long time ago. So when this Big Bang explosion took place, the matter started expanding in the universe. As you know that for something to oppose, there needs to be friction. Okay, so when the explosion started taking place, there was no friction in the atmosphere, in the space, and the galaxies, they started moving away from each other, and it is continuously expanding. So this expansion of the universe is constant and it's continuously expanding. This expanding state of universe was given by Edwin Hubble. Okay, when it says that from the point of the singularity, the universe is constantly expanding, and it is expanding at the at the speed which is directly proportional to the distance between the galaxies. Means more the distance, more is the speed of departure, or more is the rate of the departure. You know this formula, speed is distance upon time. So speed is directly proportional to distance. More the distance, more the speed. Okay. So the UPSC had asked question with respect to the expanding state of the universe, and there the question was with respect to something redshift phenomena. So redshift phenomena is basically when the universe is expanding, the frequency of the light or the energy that is coming from the distant galaxies, that frequency keeps on decreasing. Okay, and in the spectrum of the light, we say that the shift in the frequency is towards the red, so the term redshift phenomena is being used. You must be relatively aware about these facts. Everything that is there, okay, the planet, sun, moon, asteroid, galaxies, everything this is universe. And there are several galaxies. Within the galaxies, there are a set of sun, moon, or the planets or the asteroids, etc. And within the Milky Way galaxy, the solar system, and within the solar system we have sun, we have 8 planets, we have several hundred of moons collectively. Okay, and we have asteroids. Now this is very, very important diagram. Here let us try to understand maximum information. Here sun and the different planets are there, the asteroid belt is there, even the Kuiper belt is there. Okay, I have also tried to mention the relative distance of each of these planets with respect to sun. Okay, I have also mentioned the difference between the inner planets and the outer planets. Okay, so let us try to understand this. With respect to the sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, we have these planets. With respect to distance from the sun, we have just studied that the average distance between the sun and the Earth is called as astronomical unit, which is 150 million kilometer, which we take it as 1 Armstrong unit, 1 astronomical unit. Okay, so Mercury is 0.4 astronomical distance, this is 0.7, this is 1.5, so on and so forth. So the distance keeps on increasing. Okay, and astronomical unit is 150 million kilometer, which is an average distance. And why do we measure the distance in terms of the light? Because light, the speed of the light is always constant, irrespective of it is moving in the solid, liquid, or gaseous, any of the states, it remains constant. Okay, the speed of the light is not always straight, it can bend. It bends because of gravity. If there is a strong gravitational force, like for example black hole, okay, the bending of the light can also take place. Okay, so it is not the case since light is traveling in a straight line, so we use light for the measurement of these distances. It is basically the the uniformity with respect to the speed. Okay, with respect to that of the Earth, which is the nearest planet, Mercury is the nearest planet, and we can even see this. Okay, in the morning or the evening, Venus is also known as the morning or the evening star. The second closest is Mars, the third is Mercury, then the fourth is Jupiter. Okay, then Saturn, Uranus, and Neptune. Okay, so just remember these two. Venus is closest one, followed by Mercury. Mars, followed by Mercury, and then the Jupiter, and so on and so forth. These four planets are inner planets, these are outer planets. You can see the difference between them. The inner planets are relatively short, these are relatively bigger. UPSC will ask question why these are relatively shorter. Analytical questions, analytical based questions. So these are relatively smaller because they are very close to that of the sun, and because of that the atmosphere that they had got blown away. The solar heat storms or the solar waves, it blew away the atmosphere. Okay, also these planets have relatively lesser gravity. The gravitational influence of these planets are relatively less as compared to these planets. These planets are bigger. The reason is they are far from the sun. The solar influence could not blow away their atmosphere, and they have a very, very strong gravity. Because of that, they are holding their atmosphere. So they, in terms of appearance, they look big enough, but they are basically gas. They are basically gaseous in nature. The rock solid part would be relatively small only. Okay, so from far off they look bigger. So since they are mainly made up of gases, so they are also known as the gaseous planet. Okay, and also the outer planets or the Jovian planets, these are inner planets or the rocky planets or the terrestrial planet. They are basically Earth-like. Now let us see the difference between the asteroid belt and the Kuiper belt. So asteroid belt, what do they have? They are basically the celestial bodies which is mainly made up of rocks or the gas, okay, or the dust particles. Okay, rocks, gas, or the dust particle, and there is the biggest asteroid, that is the Ceres. Ceres is the biggest asteroid. Ceres is also a dwarf planet. So dwarf planet is the one which is not following the full criteria of being declared as a planet. Then when it comes to the Kuiper belt also have rocks, the dust particles, and the ice crystal. So one difference between the asteroid belt and the Kuiper belt, that is Kuiper belt have the ice because they are very, very far from the sun. So it is the sun influence is not much, so some of the gases are also there in the ice forms. Okay, asteroid belt, some of the rocks from the asteroid belts, some asteroids they do happen to fall on the different the planets. And when it comes to Earth, so Earth have atmosphere. Under the influence of the Earth atmosphere, it heats up and it burns and it forms the meteor. When many of them falls, it forms meteor shower. Okay, so UPSC have asked question related to the difference between the asteroid belt and the Kuiper belt. Okay, so you may expect a fundamental question when it comes to the size of the planet. Okay, when it comes to the size of the planet, just mug up this fact. Okay, we know the sequence of the planet with respect to the sun. The size is also very, very important. Now, very, very simple. See, the outer planets, the four outer planets, that is Jupiter, Saturn, Uranus, Neptune. So this sequence is simple. Okay, within the inner planets. So this sequence is simple within the inner planets. Which is the biggest one? Earth, followed by Earth twin or the sister planet. Okay, also known as the twin planet, that is the Venus, followed by Mars. Mars is half the size of the Earth, and the smallest one is the nearest one. Okay. So I hope you remember the sequence: Jupiter, Saturn, Uranus, Neptune. Inner planets में the biggest one will be Earth. Earth का twin planet Venus. Earth का half वाला is Mars, and the smallest and the nearest one is the Mercury. Okay, I hope you got this thing. Okay. Now with respect to the formation of the moon. Okay, we saw the Big Bang, we saw the formation of the sun. Now it is the time of moon. With respect to the Earth, how the moon was formed. So one asteroid which was similar to that of the size of the Mars, it came, hit the Earth, and the Earth broke up into two parts. The bigger one continued to be Earth, and the smaller part which got chipped away from that of the Earth, that formed the moon and started revolving around that of the Earth. Okay, so when one rock hits another rock, a splat noise comes. So in the similar way, this event is termed as a big splat event, which took place 4.4 billion years ago. It means after 2 million after the formation of the Earth. Okay, so when it comes to the rotation and revolution, some of the facts, if we can memorize. So we know the sequence of these planets. Okay, we know that the speed is directly proportional to the distance. We know this formula, and we also know this formula that time is directly proportional to distance again. So more distance, more time it will take. Okay, so in terms of revolution, when the planet is close to sun, less distance, less time for revolution. When it is like further planets, more distance, more time for the revolutions. So you can just remember the sequence with respect to the revolution. Rotation the sequence is like not very uniform. It's not very uniform. So you may just mug up some of the facts over here. Okay, we'll come to these facts once again as we do the rotation and the revolution. With respect to the evolution of the Earth, okay, or evolution of the living organism, so how did this Earth evolve? In detail, we shall be doing this in geomorphology, climatology, oceanography. So here, when the Earth was formed in the initial stage, it was very hot, and the majority of the atmosphere of the Earth was hydrogen and the helium. Okay, hydrogen and the helium, and that was the case with most of the planets. Then the solar wind came. The solar wind blew away most of the atmosphere, and the atmosphere of the Earth got reduced. Also, over a period of time, the cooling of the Earth atmosphere took place because of degassing. Degassing, what happened is the various gases from the interior of the Earth, they came out. Why? Because of the difference in the gravity. Difference in the density. The gases are relatively less denser, it rised up, and the solid material is relatively more denser, it went down. Okay, because of difference in the density, this degassing took place. Okay, and these new composition of the atmosphere was added. So water vapor, nitrogen, carbon dioxide, methane, etc., all of these were there. Carbon dioxide was quite huge in terms of concentration, and oxygen was quite little. So it was not possible for the survival of the living organism. But then what happened was the living organism, that is the blue-green algae, it came into the water, that is the cyanobacteria. It came in the water, and it started doing chemosynthesis. That is, they prepared their food through chemical reaction. On this sequence, evolution of living organism, there are three prelims questions. So you must remember this sequence. That is, the first living organism, first life came in the water, that was cyanobacteria, blue-green algae. They prepared their food through chemosynthesis. 3,800 million years ago they came. When they were available, so blue-green algae, which started doing photosynthesis, that came. Blue-green algae, they started doing photosynthesis, means they started taking carbon dioxide and they started releasing oxygen. They started taking carbon dioxide, they started releasing oxygen. Where did this carbon dioxide came from? They came from the atmosphere. Okay, so atmospheric carbon dioxide got mixed with the water. Okay, and water ka carbon dioxide was taken for photosynthesis by this blue-green algae. Okay, then this oxygen was released into the water and then into the atmosphere. So carbon dioxide concentration from atmosphere started decreasing, oxygen concentration in the atmosphere, they started increasing. This was also a UPSC question. Okay, after that, when there was sufficient concentration of the oxygen, then the aquatic animals came up. Okay, followed by that of the amphibians, which could live in the water as well as on the land. Then came the reptiles, which were 100% living on the land. Then came the mammals. Then came the flowering plants. okay, and the birds, etc. Okay, so in this way the evolution of the living organism took place. Okay, so I hope you would remember the sequence: cyanobacteria, blue-green algae, aquatic animals, amphibian, reptile, mammals, and the flowering plants. Okay, parallelly there were many things that were happening. Changing composition of the atmosphere was taking place, change in the composition of the ocean that was taking place. So many things with respect to the geological evolution of the atmosphere was taking place, also that of the overall earth. Okay, so when we look into the geological time scale, the Big Bang event, when did this Big Bang event took place? So it took place somewhat 13.7 billion years ago, wherein the origin of the universe and various other celestial bodies took place. Subsequently, the origin of the stars, okay, roughly 5 to 6 billion years from the present. Okay, UPSC may ask question related to these sequence, followed by that of the living organisms, and the 4.4 billion years ago the big splat event took place, wherein the moon formation happened, followed by that of the evolution of the atmosphere, evolution of the ocean that took place, and parallelly other things like the living organism, they started coming up in the into the water bodies. So first, I hope you remember, that is the cyanobacteria, blue-green algae, then the marine invertebrates, then the fish, amphibians, reptiles. Okay, then these are reptiles only. Okay, then small mammals, then the flowering plants, and then the human beings. Okay, so I hope you would remember this sequence. Also remember some of these some of these geological time. Like for example, you must be knowing this in the case of the geological time scale, which is the biggest time, that is eon, followed by era, followed by period, followed by epoch, and then the age. Again, a question may be framed over here. Okay, eon, era, period, epoch, and age. So you may make some code to memorize this fact. Here on this sequence, 3 questions were asked. So we'll try to take some of them so that you have an understanding that UPSC is asking question on the concepts, and concept based questions are asked till date. So you may never take it this way, that UPSC is always focusing on the current affair. So here you can see this is a current affair based question, quite a simple question. So here you can see the term event horizon, singularity, string theory, and standard model, sometimes seen in the news in the context of. So it is current affair based question, but can you do it with the help of the concept singularity? Okay, we just saw singularity. So it was associated something with respect to that of the origin of this origin, or the formation of that of the universe. Okay, so here quite a number of students got confused with option number A and D. Option A says observation and understanding of universe, whereas option D says origin and evolution with living organism on earth. Okay, living organism that of the earth. So it is with respect to that of the universe, not specifically with respect to that of the earth. So A is the answer. Okay. Now in 2018, UPSC had asked question here. So the question is, the Earth's magnetic field has reversed a few 100,000 years. So we are going to do this magnetic field, but for timing, let us assume that we don't know this statement. So when you don't know any statement, okay, so it may be either right or it may be wrong. Okay, it may be right or it may be wrong. So looking for the another options, another statements. Statement 2 says, when the Earth was created more than 4,000 million years ago, there was 54% oxygen. 54% oxygen and no carbon dioxide. So this is absolutely wrong. We just saw that carbon dioxide concentration was quite high. On the other hand, oxygen was very little. Presently, the oxygen composition is just 20-21%, right? So it could not have been 54% in the past. So this is a wrong statement. Third, when living organism originated, they modified the early atmosphere of the earth. Yes, they modified. Now this is a general statement. General statements are usually correct. Whenever the statement have got some data, some facts, usually they are wrong. Okay. So I hope you can answer this. since statement 3 is correct, C is the answer, which means 1 is also the correct statement. The Earth magnetic field has reversed every few 100,000 years. This is correct. Now it is actually because of this Earth's magnetic field, which was there in the news in 2018, the question came. Nowhere it is mentioned anything with respect to the current affair, but it is a current affair based question. It is a conceptual question from current affair. So let us say you might have missed this current affair, or you might be reading just one newspaper, yes or no, and this happened to come in some another newspaper. So basically the news was the Earth's magnetic north pole is shifting, and it have shifted considerably to a greater distance, and this was creating problem with respect to that of navigation. So upgradation of the navigation system, okay, that was being undertaken, and it is for this reason that it was there in the news. Okay, and from that context a conceptual question was formulated. Okay, so whichever topic you take, okay, take the reference from current affair, but do it in depth from the standard material. Okay, we had studied that when the universe was formed, the expansion of the universe took place, okay, and very rapidly. Here if we do the anatomy of the Milky Way galaxy, so this is somewhat a Milky Way galaxy looks like, and the diameter of this Milky Way galaxy is roughly 1,25,000 light years, so it is quite big. It is estimated that around 200 to 400 billion stars are there, and roughly 100 billion planets, and 500 million of which may support life. Okay, may support life. Let us proceed ahead with this topic. This is quite important, the revolution of the planets. Okay, the revolution and the rotation of the planets, both are very important. First we'll do the revolution, and then we'll do the rotation. Rotation is relatively more important, and there are good number of questions on this rotation and revolution. So revolution of the planet, we know that all the planets revolve around the sun in the in a particular order. So there are basically 3 laws to define these revolution. First law is the law of orbit, which says that all the planets revolve in the elliptical orbit from the west to east direction, or we say anti-clockwise direction. All planets, okay, all planets anti-clockwise direction or west to east direction. Okay, now with respect to rotation there is some differences. Okay, so we'll see that later on, but with respect to the revolution it is constant. Then the law of the area, what does it say? That the planets are not forming a circular orbit, it is elliptical orbit. So at time it is close to the sun, at time it is far from the sun. Okay, and the average distance that they cover while moving close enough or while moving far enough, the average distance or the area that they are covering is constant. Okay, they are constant. See, when the planet is close to that of the sun, there is a gravitational influence, yes or no? So the gravitational influence might be relatively higher when it is close enough, because the concept related to the gravity, that gravity is directly inversely proportional to that of the distance. When the distance is more, gravitational influence will be less. When the distance is less, gravitational influence will be more. Okay, I hope you know that Newton's law of the gravitation. So when the distance is less, gravitation is more. So don't you think when the planet is close, it should be pulled by the sun? Similarly, when the distance is far, the gravitation influence should be less. Don't you think due to the centrifugal force, because something in the rotation or revolution have the centrifugal force, it should be thrown away, but it does not happen. So it is because of this law of conservation of angular momentum. Okay, so here in this case it moves relatively faster, okay, to avoid being pulled by the sun. Here the speed of the revolution is relatively slowed down. Okay, and because of this they are able to maintain the momentum. Okay, they are able to maintain the momentum. Okay, when it comes to the law of time, that how much time one planet takes for one revolution, so it is governed by a simple formula. There is no need to go into the formula as such. Okay, just see with respect to that of the relation. So this formula, speed is equals to distance upon time. Okay, which means time is directly proportional to distance. More distance, more time. In the simple manner, there is one derivation with respect to the revolution of the planets around the sun. So this derivation says time square is directly proportional to average distance ka cube. Average distance. So we know that distance is at time close, distance is at time far away. So we take the average distance and average distance ka cube. So more distance, more time it will take, isn't it? Okay, so here in this case Earth takes 365 days. So lesser will be taken by Venus, much less will be taken by the Mercury. So in terms of revolution, Mercury will have the shortest duration of revolution, followed by Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune. Of course Neptune is also there. Okay, so the longest, the further the longest. Okay, but when it comes to rotation, the rotation where there is no uniformity. So here the factual thing that I had said with respect to the rotation and the revolution, that is whenever such long data comes, okay, when you have to memorize a lot of information, so never memorize the huge amount of the information, because there is high chances that you will forget all of them. Okay, so very simple thing is that try to remember the trend. Always go in the trend wise manner, always try to remember the trend. Okay, so the UPSC had asked question with respect to the rotation and the revolution also. So let us take one or two questions with respect to the revolution and then we'll proceed ahead with the rotation. So here is the question. You can see there is a question related to the difference between the asteroid and the comets. So okay, so this is quite a concept based question. Instead of focusing on these type of questions, so we must see the concept based. That was a very fact based question, fundamental. Here, which one of the following is the reason why astronomical distance are measured in terms of light years? So it is the speed of the light is always same. Okay, D is the answer for this. Then if we take with respect to this question, question number 18. To orbit around the sun, the planet Mars takes lesser time than the time taken by the Earth. So is it correct? Absolutely no, because to orbit around the sun, Mercury, Venus, Earth, Mars. So Earth will be taking less time, followed by the Mars. Mars will be taking more time, right? So assertion is false. The diameter of planet Mars is less than that of the Earth. This is correct. Okay, this is true. The Mars is half the size of that of the Earth. So definitely this statement is correct. Okay, quite a concept based question. Here again, among which one of the following planet takes maximum time for one revolution around the sun? So maximum time will be taken by the one which is farthest one. Okay, so here the answer would be the Jupiter. Okay, and in terms of the solar system, it will be Neptune. Okay, so I hope you're understanding these concepts. Let us proceed ahead with the rotation of the planet. Now, rotation of the planet, there are many concepts and there are many questions. So here, with respect to that of the rotation, let us revise revolution. We had studied that in revolution, all the planets revolve in the anti-clockwise manner or the west to east direction in the elliptical orbit. When it comes to rotation, rotation wise also, it seems all planets except Venus and Uranus, rotate in the west to east direction. Okay, except Venus and Uranus. So Venus and Uranus rotate in east to west direction. So you can see from here that except Venus and Uranus, okay, except Venus and Uranus, all the planets are revolving in the west to east direction. Okay, So with respect to that of the theory, there is no specific theory with respect to the rotation, because the rotation of each of these planets, they do not follow any uniformity or constant observation. So here there is no specific theory as such. With respect to rotation, there are effects of rotation, especially with respect to that of the Earth. There are 5 effects. There are many more effects as such. UPSC have mainly asked question on these 5 effects, and we shall be focusing on all of these 5. So what happens because of the rotation of the Earth? The shape of the Earth gets changed. Okay, it becomes oblate shape. So Earth used to be like more of spherical in nature, but because of the rotations. So because of rotation, what happened is, when this is the axis of the rotation, vertical axis of the rotation. So when it is rotating, so certainly there is a centrifugal force. So from the center, the object tends to move away. So from the equatorial region, from the middle, the Earth is expanding, and from the pole side, it is contracting. Okay, it is contracting. So here, for that purpose, you can see there is a difference with respect to that of the radius of the Earth at the equator and at that of the poles. So the radius at the equator is more, radius at the pole is relatively less. Okay. Now here, one more concept you can see, that gravity is equals to gm1 into m2 upon r square. So these are two mass of the object and the distance between these two objects. Okay, so in simple words, gravity is directly proportional to mass, and gravity is inversely proportional to the distance between the two objects. So gravity is inversely proportional, means more distance, less gravity. Yes or no? More distance, less gravity. Second formula, we know weight is equals to mass into gravity. Okay, weight is mass into gravity, which means weight is directly proportional to gravity, right? More gravity, more weight. Okay, more gravity, more weight. Okay, so if I try to relate these two now, okay, weight is directly proportional to gravity, gravity is inversely proportional to the distance. So in simple words, weight is inversely proportional to the distance. I hope you have understood this derivation. So here what I am trying to say is, here gravity at equator, since distance is more, gravity will be less. Distance is less, gravity will be more. Yes or no? So when the gravity is more, weight is more over here. Gravity is less, so weight is also less over here. Okay, once again, more distance, less gravity, less weight. Less distance, more gravity, more weight. So if you do the measurement, or if you weight an object, okay, at pole and at the equator, at pole weight will be more, and at the equator weight will be less. This was a UPSC question. Okay, at pole weight is more, at equator the weight is less. Okay, so I hope you're understanding these concepts, because concept based questions are evergreen and UPSC have asked questions. So we'll do a couple of questions together. Because of rotation, we get day and night. Okay, so you can see this is the axis of this rotation, and the axis of the rotation is tilted by some degree. I hope you know that is 23.5 degree it is tilted. Okay, and when the sunlight is available, so sunlight won't be tilted that way. Okay, the sunlight will be straight. Okay, it will be straight relatively, because the gravitational influence is not so strong enough to bend it. So this dotted line, as you can see, till where the sunlight is able to fall, so this is the line of, or the axis of illumination. Okay, illumination is basically the brightness or the light. So this is the tilted axis or the axis of rotation. This is the axis of illumination. Okay, so on one side we get day and one side we get night. Also because of rotation we get time and date. Okay, time and date. And in order to understand time and date, we will be studying first latitude and longitude. Here one fact is that day and night is because of rotation. We studied, but have you seen that during the summer day is longer and night is shorter, and during winter it is opposite, night is longer and day is shorter? Why is that? It is because this variation in length of daytime and nighttime is not because of just a rotation, it is revolution. Okay, it is revolution along the tilted axis. Revolution along the tilted axis. We'll try to do this little more in detail in the subsequent topic. Okay, this was also a 2013 UPSC question. Okay, so with respect to the time and date, we'll first understand latitude and longitude, then we'll proceed ahead with understanding of the time and date. So here, with respect to this latitude, first we'll focus here. Latitudes are the horizontal line. The very important latitudes are this equator, tropical Cancer, Capricorn, Arctic Circle, Antarctic Circle, and the North Pole and the South Pole. There was a question in 2019 related to this. Okay, so don't take it lightly that you know latitude and longitude. Many students made mistake even after knowing this latitude and longitude, because UPSC is asking in-depth question, and you should not study you should not just have this shallow information. Just knowing the term does not mean you know the topic. You have to go into the detail of the topic. Okay, so here with respect to this latitude and longitude, we saw this the earth is tilted by a certain degree, so certainly all of these important latitudes would also be tilted accordingly. Okay, what is the use of this latitude? The latitude is used for measurement of the distance. Equator divides the earth into north and the south hemisphere. The distance between two latitude is 111 kilometer, and the biggest latitude, as you can see, the earth is a sphere, so this is relatively big, and the latitude size is decreasing, and the smallest latitude is the North Pole, and the biggest latitude would be certainly the equator. So the biggest one is equator and the smallest one is the pole. Okay, now let us try to understand what is longitude. So longitude is again the vertical line running from poles to pole. Okay, the earth is a sphere, so certainly there are 360 longitudes. Okay, the 0 degree longitude divides the earth into east and west hemisphere. The distance between the two longitude is not constant. Okay, it is the farthest at the equatorial region, okay, which is 111 kilometer, and at poles they meet, so certainly the distance is 0 kilometer, and longitudes are of relatively same size. Latitude ka size keeps on decreasing. Okay, but the latitude ka distance between two latitude is constant, but longitude ka distance between two longitude is not constant. Okay, now with respect to this latitude and longitude, if we intersect latitude and longitude, we get specific location or specific point. Okay, and this is basically used in the navigation systems. Okay, so when it comes to longitude may very important with respect to the date and time. So earth is divided into east and the west hemisphere because of this 0 degree longitude, which is known as prime meridian or GMT. Now east hemisphere, west hemisphere. So we know that on the earth it's not same date throughout the earth. So on one half of the earth it is one date, and on the another half of the earth it is like the one date behind. Okay, so earth rotates from west to east direction. West to east direction, it means the eastern region will get the sunlight first. Okay, will get the morning first, will get afternoon first. So this will have the day first, and when it is day over here, it is night over here. So they will be having first time is first date, take an earlier date, and then when this is going to go towards the brightness, this will turn into the dark region, and then this region will have the morning, and then they will be having the respective time and then the date. So they will be leading in terms of date and time, they will be trailing. Okay, so if it is let us say 5th April over here, if it is 5th April, then it is 4th April. Okay, if it is 1st January, it is 31st December. I hope you're understanding this. And there is an international date line, this 180 degree longitude, east or the west is the international date line. Okay, so if we take the earth the other way, okay, so this is the east hemisphere here, and this is the west hemisphere here, and the international date line is in between. So if it is like what I had said, like this will be having the earlier date, let us say it is 12th October, so it would be 11th October. So 12th October and 11th October over here. So if you cross the date line, there is a question related to this also. So if you cross the date line, this is which hemisphere? This is the eastern hemisphere, this is the western hemisphere. So if you are moving eastward of international date line, statements, these words, these keywords are very, very important. If you are moving eastward of international date line, so you will get 12th or 11th October you had already got it yesterday, and now you will get 11th October again. Yes or no? So if you are moving eastward of the international date line, you will gain the time, and if you are moving westward of the international date line, you will lose the time. I hope you are understanding this. There can be a question here once again. Okay, so I hope you are understanding the concept of gaining and losing the time, the latitude and the longitude. A very, very important longitude here with respect to that of the India. So you know the geographical the extent of India, especially in terms of the longitude. We are 68 degrees 7 minutes east, the westernmost extent, and the easternmost extent 97 degree 25 minutes east. Okay, so there is a distance of 30 degree. There is a distance of 30 degree in between this longitude. Okay, and we have taken 82.5 degree east as the Indian standard time. Okay, we have taken 82.5 degree east as the Indian standard time. So here try to understand one thing, that for the rotation of the Earth, that is 360 degree rotation, it takes 24 hours, which means 15 degree rotation in 1 hour, which means in 2 hours it will rotate 30 degree, which means now that when the sunlight is here, when the sunlight is in the easternmost longitude, it will take 2 hours for the sunlight to come to the westernmost longitude. Do you agree? It will take 2 hours for the sunlight to come from the easternmost longitude to the westernmost longitude. So ideally we should have 2 time zones, 1 hour ka 2 time zone. Okay, but the concept of the time zone is not known. It will be very, very new to us, and it may create a lot of issue with respect to the common citizen understanding the time zone. Also it may create issue with respect to the administration and governance. So for that purpose, usually this is avoided, and we are having 1 time zone only. Okay, that is our Indian standard time is 82.5 degree east. So whatever is the time on this, the same time is considered all over India. And this 82.5 degree east from prime meridian, from 0 degree longitude, how much distance it is? 82.5 degree east. So it will take roughly 5 hours 30 minutes for the sunlight to move from this longitude to this longitude. And since sunlight will first come here then go here, so that is the reason why we write plus, that is we are ahead of prime meridian. Okay, there was one question related to the international dateline. This is very, very important. See, international dateline we considered 180 degree longitude. Okay, 180 degree longitude, but 180 degree longitude is straight line, but international dateline is not straight, because let us say this region, this is the Siberia region of Russia, and if we consider international dateline, it would pass through the Siberia. So it means Siberia mein, on one part it will have another date, and the second part will have some other date. Okay, so in one country there will be 2 dates, 2 different dates, so it will be difficult for them to do the administration. Already they have different time zone, but they have same date. If there is a different date on the same country, certainly it is going to be a big problem. So what is being done is, for the administrative convenience, this time zone is modified. Okay, this time zone is modified, it is bent, okay, as per the convenience. Now this this international date line is not universally accepted date line, because let us say USA have their island, they have some island over here, and the same island is like a disputed island with the another country. So they will say that the date on this island is X, this country will say the date on this island is Y. So there can be dispute with respect to the real date. So for that purpose, international date line is not considered universally or not accepted universally by all the countries. Okay. Now UPSC had asked question with respect to the international date line passing through which region. So certainly it will not pass through any land, because if it is passing through land, that land will belong to some country and it will create problem with respect to the distribution of the date. So here it passes through the seas. So it starts from North Pole to South Pole and Arctic Ocean, Chukchi Sea, then this is the Bering Strait, then Bering Sea, Pacific Ocean, Ross Sea, and then the Antarctica Glacier. Okay, so Chukchi Sea, Bering Strait, Bering Sea, Pacific Sea, Ross Sea, and then the Antarctica. Okay, I hope you would remember these facts. Okay, so here with respect to understanding of some of these questions, it's time that we should focus on some of these questions. So see over here. So we had studied the rotation of the planets and their effects. Yes, here is the question that I was talking about. Variation in length of daytime and nighttime from season to season is because of day and night is because of rotation. Variation in length of day and night time is because of revolution of the earth along the tilted axis. Okay, effects of rotation, we saw the oblate shape of the earth, that is geoid. Okay, and here is the another question that I was talking about. The weight of the body decreases with the increase of latitude on the earth. So equator mein, what did we study? Equator mein distance more, gravity less weight. Pole mein distance less, gravity more weight. So pole mein more gravity and equator pe less gravity. So equator is low latitude, zero latitude, and pole is 90 latitude. So from 0 latitude to 90 latitude, if I move from 0 to 90, so weight will keep on increasing from less weight to more weight. So weight will keep on increasing. And what is the question? Weight of the body decreases with the increase of latitude. No, it increases. Assertion is wrong. The earth is not a perfect sphere. This is correct. Assertion is wrong. Okay, we get day time and the day and night. We have also seen with respect to that of this latitude. So here with respect to that of the latitude, we know that the earth is tilted by 23.5 degree. Okay, earth is tilted by 23.5 degree. Okay, so and earth is also revolving. Okay, earth is also revolving around that of the sun. So because of this revolution, we do not get the similar length of the daytime and the night time. Okay, so when we consider this position of that of the earth, when it is at this position, so it is the June 21st or 22nd June. Okay, 21st or 22nd, the sunlight is directly perpendicular to this latitude. Which is this latitude? This is 23.5 degree north. Okay, that is perpendicular to 23.5 degree north. When the earth revolves and come to this position, the sunlight is perpendicular to that of the 0 degree longitude. Okay, so 0 degree longitude, so all the earth, the entire earth will have equal proportion of the illumination. So that is termed as the equinox, which is September 22nd, 23rd, wherein the entire earth will have equal day and night time, 12 hours day, 12 hours night. Whereas in this case, the northern hemisphere will have summer and will have longer day. Southern hemisphere will have winter and it will have shorter it will have the shorter daytime, and shorter daytime means longer night time. Okay, when it comes to this position, equal day and night time, so equinox. Okay, when it further revolves, the sunlight is perpendicular to that of the 23.5 degrees south latitude. So it is summer in the southern hemisphere, winter in the northern hemisphere. So longer daytime, shorter night time, and longer night time and shorter daytime. So it is the winter in the northern hemisphere. So it is the winter solstice, wherein the night is longest in northern hemisphere. night is longest in the northern hemisphere and day is longest in the southern hemisphere. Okay, here it is the day is longest in the northern hemisphere and the night is shortest in the night is longest in the southern hemisphere. Okay, and ultimately when it again revolve in this direction, okay, here again the sunlight will be perpendicular to the equator, again equal day and night time, again it is equinox, and accordingly it will move. So we get the variation in length of the daytime and night time, and this variation is because of the revolution along the tilted axis. UPSC had asked one question in northern hemisphere. Longest day of the year normally occurs on longest day of the year in the northern hemisphere. We just saw it will appear on when it is summer plus it is the June. Okay, so June 21st, 22nd, roughly it is the 19, 20, 21st June, 19, 20, 21st June. It depends upon the the leap year, all of those considering. So it is roughly the June. So it is first half month of the June. First half means initial 15 days, no. Second half month of the June, yes. Second, this is correct. First half month of July, no. July is not there. So B is the answer here. If we take this next question, on 21st June, the sun. So it is a repeated question 2019-2022. Okay, concept based question. On 21st June, the sun is perpendicular on Tropic of Cancer, northern hemisphere. It is summer solstice. Okay, simple. The sun shines vertically overhead. So now here the statement is not very straight enough. Option A says does not set below the horizon at the Arctic Circle. Okay, so here I hope you know this. This is the Arctic Circle, Tropic of Cancer, equator. So beyond the Arctic Circle, it is 24 hours ka daytime. So sun does not set only when it is 24 hours ka day. Yes or no? Same time pe, let us go to the southern hemisphere. Southern hemisphere, it is winter, and when you go to the south pole, it is 24 hours ka night time. So sun is completely set in the southern hemisphere. Okay, so especially in the south pole, and sun does not set. Okay, or it is 24 hours ka daytime in the north pole. I hope you are understanding this. So beyond Arctic Circle, sun does not set on 21st June or roughly during those time. Sun does not set below the horizon at Arctic Circle. Sun does not set below the horizon at Antarctic Circle. It have already set because South Pole it is night time. Shines vertically overhead noon at the equator. No, it is Tropic of Cancer. Again, Tropic of Capricorn nahi hai, it is Tropic of Cancer. I hope you are understanding these questions. This we have just solved. Longitude wala question. Longitude, prime meridian ke liye very important. There was one question related to this, very concept based question, very nice question related to this longitude. So we saw prime meridian, it is the 0 degree longitude. So which region or which country it passes through? It passes through UK, okay, and in London Greenwich Mean Time, Greenwich. Okay, so UK, France, Spain, Algeria, Mali, Burkina Faso, Togo and Ghana. Okay, once again, UK, France, Spain, Algeria, Mali, Burkina Faso, Togo and Ghana. And then it will be the Atlantic Ocean. Further in the Antarctica at South Pole it will join. So all of these countries which is on the similar longitude will be having relatively similar time. Yes or no? Similar time. So countries lying on the similar longitude have relatively similar time. And that was the question being asked. Here with respect to the prime meridian, international date line, you can see it is not very straight. It is zigzag and it is not universally accepted also. Which one of the following strait is nearest to the international date line? It is the Bering Strait. We have seen this. Gaining and then losing the time, we have understood. The Indian Standard Time also we have understood. Now here we had understood that it is 82.5 degree east longitude. So which all state it passes through? It passes through Uttar Pradesh. Okay, Mirzapur is considered as the ideal point from where it is passing. So little bit of Madhya Pradesh also it touches, then Chhattisgarh, then Odisha also, and Andhra Pradesh. Okay, no Telangana. It is close enough, but no Telangana. So once again, Uttar Pradesh, Madhya Pradesh, Chhattisgarh, Odisha, and Andhra Pradesh. Okay, no Telangana. Okay, because why we are doing this? Because UPSC has one question related to tropical cancer. Tropical cancer passes through 8 states in India, that is Gujarat, Rajasthan, Madhya Pradesh, Chhattisgarh, Jharkhand, West Bengal, Tripura, and Mizoram. So it passes through these states, and UPSC had asked question with respect to cities through which they are passing. So we should be safely, we should be doing this also. Okay, that is analytical based preparation. Here, with respect to that of another important topic, we have to focus on this topic, because this is quite important. Okay, and the importance of this is from the climatology aspect. Okay, the deflection of the direction of fluids. So here, with respect to the deflection of the direction of the fluids, so we have studied that the earth is rotating from west to east direction. Because of this rotation, of force known as the Coriolis force is produced. Okay, what is the job of this Coriolis force, or what does it do? Okay, so it acts on fluids. Fluid is something that can flow. It can be water, it can be air. Okay, so it deflects the direction of the wind and the oceanic currents. It deflects, or it changes the direction of wind and the oceanic current. Here, with respect to that of the deflection, in northern hemisphere it deflects it towards the right hand side. In southern hemisphere it deflects towards the left hand side. Okay, north may right and south may left. And what amount of deflection? This deflection is directly proportional to sine theta, which means that at the equator sine 0 is 0, 0. 0 means minimum deflection. And at pole may theta value is 90. Okay, sine 90 is 1. 1 is maximum value of sine theta. So maximum deflection at poles. So equator pay minimum deflection, poles pay maximum deflection. Okay, I hope you are understanding this. So which means that if I am going, take north hemisphere, I am going from equator towards pole. Okay, the wind, or you take oceanic currents, okay, it will keep on deflecting towards the right hand side, and degree of deflection will keep on increasing. More you go from equator towards pole, the degree of deflection keeps on increasing. Similarly, if you are coming from pole towards equator, from pole, so degree of deflection at the pole will be maximum, and at the equator it will be minimum, but it will be towards its right, not your right. Okay, right of the fluid. Okay, right direction of that of the fluid, not ours, not your right. Similarly, in the southern hemisphere, it is deflected towards the left hand side. From equator, if we go towards that of the pole, the deflection is towards the left, and the degree of deflection keep on increasing from equator towards pole. Similarly, from pole, if you are going towards the equator, deflection is towards the left only, and pole pay maximum, equator pay minimum. This much should be understood, and there are 2-3 questions related to the Coriolis force also, and Coriolis force related questions are mainly asked in climatology. Okay, when in the wind direction, okay, that will come into picture. That time this question will be there. Let us proceed ahead with the understanding of moon. Okay, so moon was created 4.4 billion years ago through this big splat event. Is an only natural satellite of that of the Earth. So Mercury, Venus, no moon. Earth पे 1 moon. Mars पे 2 moon. Okay, and there are multiple number of moons on the outer planets. Okay, Jupiter, Saturn, Uranus, Neptune have many moons. Okay, no need to remember the individual number as such, but you must be knowing which planet have maximum number of moon, which planet have no moon. Earth have only 1 moon. The name of the moon is Luna. Okay, so with respect to that of the moon is revolving around the Earth. Moon is also rotating. Like Earth is rotating, Earth is also revolving around the sun. Similarly, moon is rotating, moon is revolving. So rotation of the moon is 27.3 days. Revolution of the moon is also 27.3 days. Gravity on the moon is 1.6 meter per second square. What is the gravity on the earth? It is 9.8 meter per second square. Okay, and we can never see the other side of the moon. Okay, because of this fact, rotation and revolution time is same, and this fact is termed as this tidal locking, and because of tidal locking you cannot see the other side of the moon. We'll try to understand this. There are some important satellites also sent. So with respect to that of moon and the earth, the moon is also revolving around the sun in elliptical orbit, which means the distance is not constant. It is 3.6 lakh kilometer when it is closest, known as perigee. It is 4.05 lakh kilometer when it is furthest. Okay, that is the apogee. Okay, so moon, you see the relative rotation and revolution of the moon around that of the earth. So earth is revolving around the sun in the elliptical orbit. Moon is also revolving around the sun in the elliptical orbit, around the earth in the elliptical orbit. Okay, when it comes to earth, moon and sun, so they will make a very complex system of rotation and revolution. So let us focus only on moon and the earth. So when the moon is revolving around the earth, so one revolution of the moon we had studied, it takes 27.3 days. Okay? It takes 27.3 days. So in 27.3 days, earth will not be stationary over there. Earth would have also moved by a certain distance. So when the moon completes its one rotation, earth is not standing there. Earth would have moved. So it means the moon have to travel an additional distance, this additional distance, in order to cope up with that of the earth, isn't it? So that additional distance it will have to cover, and it is covered in 2.2 days. So let us try to understand this over here, that moon takes 27.3 days for one revolution. Okay, and that much time earth would have moved ahead. So moon also have to travel additional distance of 2.2 days. Okay, so it means collectively 29.5 days may it will complete its path and come back to the same position and catch the earth. Okay, 29.5 days. Okay, this 29.5 days is considered as 1 month in the lunar calendar. Okay, 1 month in the lunar calendar. So if I try to compare sun and the moon, solar calendar and the lunar calendar, so sun with respect to the solar system, 1 day is 24 hours, 1 month is 28 minimum days and 31 is maximum days, and 1 year is 365 to 366 days. Lunar may we just studied that 1 month is 29.5, multiply by 12, you will get 354. So 1 year is 354 days or 355 days in case of the leap year. Okay, and 24 hours and 52 minutes. Okay, for the 1 day is considered of that of the lunar. It's not the time taken for one rotation. Don't take it that way. Time taken for rotation and time taken for revolution is 27.3 days for moon. This is, we are talking in terms of calendar. Okay, so here if we try to understand that what type of question UPSC have asked, with respect to that of with respect to that of the calendar, the question says the Islamic calendar is 12 days shorter than that of the Gregorian calendar. Islamic calendar follows lunar calendar. Lunar calendar is 11 days shorter. Okay, 11 days shorter. We just saw 365 days and 354 days. So 11 days shorter. So it is 11 days short, not 12. The Islamic calendar began in 632 AD. So we might not know the real answer for this. But let us see the another statement. Gregorian calendar is the solar calendar. Yes. So Hindu calendar, Islamic calendar, they are lunar calendar. Lunar calendar have 354 days, which is 11 days shorter than the solar calendar. Okay. Gregorian calendar is basically the solar calendar. Okay. Islamic calendar actually began in 6 622 AD. Okay, 622, not 632. So second statement is wrong, first statement is also wrong. The only correct statement is third one. Gregorian calendar is solar calendar. Okay, now let us focus on this part now. Here I have taken Earth and Moon ka revolution. What I am trying to explain is just to see the rotation and revolution of Moon. Focus only on the rotation. First, focus on revolution. Moon is revolving around the Earth. How much time it is taking? 27.3 days. Okay? But additional it will be taking 22.2 days to cover up the additional distance. Rotation 27.3 days. Okay? Revolution. Now focus on the rotation. Is Moon rotating? Can you see the rotation? Is the Moon rotating? Just focus only on the rotation. Moon is slightly rotating. So the amount of time it is taking in one revolution, it is the same time it takes in one rotation. One rotation have started, now half, and now complete one rotation. And because of that, the same face of the Moon is always seen from whichever part of the Earth you see the Moon, you will continue to see the same face. Okay, so why do we see the same face of the Moon? Because time taken for one revolution and for one rotation by the Moon is same. Okay, let us consider a scenario when Moon is rotating faster. We can see the other side of the Moon. If the Moon is rotating much slower or not rotating also, but only revolving, in that case also we can see other side of the Moon. But it is so adjusted that the time taken for one rotation, one revolution is relatively same, and for this purpose we cannot see the other side. So same phase of the Moon is always presented to the Earth. True. Why? Tidal locking. Moon rotate about its own axis in 23.5 days. No, it is 27.3 days, right? It's not 23.5 days. Okay, so this is wrong. Okay, now with respect to the eclipse, there was question on mains, not prelims, but this year eclipse was there in the news. Just a couple of days ago, the eclipse was seen in some part of the Earth. So like every year, every now and then you can see eclipse, either a solar or the lunar eclipse. So you may expect questions. So it is the situation wherein the sunlight is being blocked because of Moon. Sunlight is being blocked because of Moon, and some part of the Earth they do not receive the sunlight. It's not the whole of the Earth, because Moon is not so big enough to cover the whole of the Earth at a time. Okay, so some part of the Earth may not receive the sunlight. So in that scenario we term this as solar eclipse. Okay, in a similar manner there is lunar eclipse also. But before lunar eclipse, let us try to understand one fact over here. Can you see the Earth, and can you see the elliptical plane, this red line? So the Earth is rotating around, revolving around the sun in the elliptical elliptical orbit. So this is basically a plane which is termed as the elliptical plane. Okay, it do not just randomly go. So out here, Moon is also revolving around the Earth. Okay, Moon is also revolving around the Earth, and the plane or the orbital plane of that of the Moon and that of the Earth is not same. So here you can see, in this case, this is the elliptical plane of that of the Earth, and this white one is the elliptical plane of that of the Moon, and they are tilted by some 5 degrees. Okay, let us have one more understanding of this. This is Earth elliptical plane, this is Moon. So if you consider this as Earth, you consider this as Earth is tilted by some degree. Moon, okay, so Moon is revolving around the Earth in this orbit. Okay, and the Earth is revolving around the Sun in this orbit. So it forms like this plane Earth ka, and this plane Moon ka. Okay, so it goes this way, Okay, so because of that, it forms an angle. It forms an angle which is roughly 5 degrees. Okay, 5 degree 40 minutes. Similarly, there is one more point. Earth is tilted by 23.5 degree, okay, from its main axis. In the similar manner, the moon is also tilted by a certain degree. Moon is also tilted by 6.68 degree, okay, it is also tilted. So it is because of these two facts, that every month, ideally you should be seeing the eclipse every month, because once in a month moon is going to come between sun and the earth. So every month you can see solar eclipse, but that is not the case. Why it is not the case? Because of this fact, that the orbital plane between that of the earth and that of the moon makes and a certain degree angle. Had it been in the same plane, then every month phenomena would have been taken. Okay. In a similar manner, we have lunar eclipse. So lunar eclipse is the condition wherein the earth is between sun and moon, and earth is blocking the sunlight. From falling on the moon. Since earth is relatively big enough, so it is going to cover the whole of the moon. I hope you are understanding this. Okay. So again, this is not a every month phenomena, and the moon or the lunar eclipse, like it is not very much highlighted one. Solar eclipse is more of highlighted, because during the daytime suddenly there is no sun. Okay, so that is very much highlighted, and over here in the case of lunar eclipse, not very much highlighted. One very important star, that is the pole star. So this is the constellation of the star, that is the Ursa Minor, okay, also known as Saptarishi. So there is one more star, 1, 2, 3, 4, 5, 6, 7, seven stars. So this is the constellation 7 star known as Saptarishi or Ursa Minor, and the last star, and this is the most brightest star also, that is known as the pole star. Why the pole star? Because it is located exactly above the North Pole, and this star is basically used for the navigation purpose to find out the particular directions. Okay, so once you get the pole star, you will get to understand this is the north, opposite of that will be south, and north ka right mein it will be east, and north ka left mein it will be west. So just by seeing a star you can see the direction, we can understand the direction. So there was one question asked by UPSC. A person stood alone in the desert on the dark night and wanted to reach his village, which was situated 5 km east of the point where he was standing. He had no instrument to find the direction, but he located the pole star. The most convenient way now to reach his village is to walk in which direction? So the dilemma here is, the person knows that from that point wherever he is standing, his village is located 5 km east, but the problem is he don't know where is east. Okay, he don't know where is west. So first thing is he must know the direction. So if he sees the pole star, the pole star will indicate the north direction. South of that, okay, south of that will be the the opposite will be the south, and pole star ka right mate is be east, and pole star ke left mate is going to be west. So when he is looking at the pole star, means if he is seeing towards the north, okay, seeing towards the north, it means he have to take a right turn. And move ahead. When it is moving towards the east, the pole star will be towards his left hand side. Yes or no? Pole star will be towards the left hand side. या फिर north pole is going to be, or north direction towards the left hand side, and he's moving straight in the east direction. So here the most convenient way, and this is also taught in the marine engineering or to the navy, merchant navy of the Indian Navy. So this what if the navigation instrument fail in the middle of the sea, and there is, like, you don't know, everywhere it is sea, and there is no particular way that you will understand the direction, so which direction you would be moving. So usually when the failure takes place during the daytime, certainly during the daytime you cannot locate where is the pole star, so they wait for the night to come, they will locate the pole star and they will see the direction and then they will move accordingly. So this is a very, very important useful question also. So let us move ahead with this life cycle of the star, and having done this topic will be over. Life cycle of a star, very, very important. Something which is born will be dying. This is the law of the nature. So nebula, I hope you remember this term nebula. Nebula is this cloud of the hydrogen gas when in the star formation takes place, okay, through the nuclear fusion reaction. So a protostar, the small or the initial or the material for the formation of the star that is going to form protostar. So after the protostar, the main sequence star or the actual star will be forming, and this star will be having relatively lesser mass, okay, lesser mass. When the mass is relatively less, so it will be forming a smaller star, for example our sun. In a similar manner, main sequence star may also have a higher mass. They will form relatively bigger bigger sun or bigger star, that is for example Regal, okay. And see the fuel for this, when do we term a star? The star is the status given to those celestial body which is able to produce their own energy, isn't it? What if the fuel is exhausted? How is this fuel produced? Because of hydrogen fusion reaction. Hydrogen fusion will lead to the formation of the helium, and helium is a relatively heavier element, okay. So when two light elements fuse, it forms a heavier element and a huge amount of energy is being released, okay, huge amount of energy is being released. Then what will happen when the hydrogen is not infinite? Are you understanding? It is not infinite. One day hydrogen is going to get exhaust. What will happen after that? So after that, what happens is the helium fusion reaction will start taking place, okay. Helium fusion reaction will start taking place, and then a much heavier element will be emitted out. At the same time, huge amount of energy is being released, okay. So as the hydrogen runs out, so when it is the main sequence star, it is relatively very, very hot and the cloud glows and there is a little bit of contraction, but it is more of a stable star and it will remain in this stage for several billion years. For example, sun is expected to be there for more 5 billion years. On the other hand, when the hydrogen fuel runs out, so what happens is it becomes relatively unstable. The core area of the star starts to contract. The outer area still have the hydrogen, so that will continue to expand, and when it expands, okay, it becomes red, okay. So for that purpose, it is known as the red giant stage of the star, okay. So what I was saying is, when the hydrogen gets exhausted, helium is there, helium fusion reaction will take place, and carbon, much heavier element, carbon will be formed. So likewise, when carbon is exhausted, helium is exhausted, carbon fusion will take place, forming oxygen. When carbon is exhausted, oxygen fusion reaction will take place, and likewise it will keep becoming heavier and heavier every time. And a time will come when it will become so heavy that it will not be able to undergo fusion, because for fusion reaction huge amount of energy is also needed, okay. And heavier elements will need more fuel or more energy for the fusion, and such amount of energy will not be available. So when it comes to this stage, fusion reaction will stop, okay, and no energy will be emitted out, okay, no energy will be emitted out. So when the energy is emitted out, so expansion takes place. When energy is not emitted out, so contraction will take place. Are you understanding this? Okay, contraction will take place, and when the contraction is taking place, there will be also a repulsive force Okay, because when the contraction is taking place, you consider this nuclei, when they are contracting, they will be moving towards each other. Okay, and there is the force of repulsion. There is a force of repulsion between the nuclei. So when the gravitational collapse is taking place, there is a repulsive force between the nuclei, and it recoils and then it expands suddenly, and this stage will be termed as the supernova explosion. Okay, supernova explosion. So here subsequently what happens is, when the supernova explosion takes place, the planet will further have different stages. That is, it may either form a neutron star or it may form a black hole. Neutron star is like those star which is 1.4 to 3 times that of the size of the sun. Black hole when it is relatively much bigger. Okay, relatively much bigger. So in the case of our sun is relatively much smaller. Sun is not going to form a black hole. Okay, for a black hole, the mass should be relatively more than the 3 times of that of the sun. Okay, so this is one of the stage wherein the star may end up. Black hole is another stage. Here also the star with a relatively low mass, what will happen to that of the sun? Sun will have one of the 2 death. So when the star is there with that of the low mass, so the inner region will start to collapse, the outer region will start to expand. Okay, outer region will start to expand. So this region will form a white dwarf star. Okay, and ultimately it will end up into the black dwarf star. Okay, but it will not form a black hole. So those star with relatively lesser mass will have a different type of end. Those star with a relatively higher mass will have a relatively different type of end. Okay, I hope you're understanding this. There was quite a number of questions asked by UPSC, especially related to the black holes, because black hole was very mysterious until recently, and UPSC had asked question related to pulsar, that is the neutron star. Okay, so there are different type of the stages of the star, all may be termed as different types of the star. Also, the main sequence star that we saw, that is relatively more stable one. When it becomes relatively unstable, hydrogen fuel exhaust out, it forms a red giant. Okay, one of the end of the star can be the planetary nebula or the white dwarf. Also, it may end up into the neutron star, which is having 20 times the sun mass of that of the hydrogen, 20 times that of the sun. And like a neutron star, there is this pulsating star. So pulsar star is something like this. There is radiations coming out from both the end, and it rotates also. So it forms a different pulse like system. So the name, the pulsar, okay, or pulsating star. Okay, UPSC had asked question related to this pulsar. UPSC had asked question related to nebulae. Okay, and Cepheids also. So it is not possible for a student to remember or know everything. Okay, like in this type of 2023 question also, even if you know 2, it is like very obvious that you should be knowing at least 2, because pulsating star, that was there in the news. And nebulae, we when we study any of the concept related to that of the solar system or Big Bang theory, this nebulae is there. Okay, so nebula is nothing but the giant cloud of dust and the gas in the space, isn't it? And pulsar is what? It is a neutron star that is formed when massive star runs out of the fuel and collapse. So statement 3 is correctly matched. Nebula is giant cloud of dust and gas. Cepheid is basically the star which brightens and dims periodically. Okay, it brightens and dims periodically. So even if you know 2 out of the 3, so even in these type of questions you can answer it correctly. So first and second is incorrectly matched, third one is correct. So answer is A, that is only 1. So basically the logic, the logic application of the logic, that will never end in the prelims. Okay, yes, the questions have remained same. The option pattern have changed. Okay, but even in this changing pattern, you can continue to add logic to such type of question and you can answer. So black hole, what is a black hole? Basically, it was theorized by Albert Einstein in 1915 in the special theory of relativity. UPSC have asked question on this general theory of relativity, and it was in 1907 again given by the Albert Einstein only, and UPSC had asked just 3-4 years ago general theory of relativity. Okay, so you must do that in science and technology. Okay, the term black hole was given by Archibald Wheeler. So Albert Einstein just theorized it, Archibald Wheeler gave the term. Okay, so black hole is the one which is having relatively very high density, very high gravity. Gravity is so high that even light cannot escape. Okay, light cannot escape. So so you cannot see those you cannot see that object. So for that purpose it is termed as black. Okay, black. For better understanding of the black hole, ELISA, that is Evolved Laser Interferometer Space Antenna, two question on this ELISA. Okay, UPSC have asked repeated question actually on ELISA. Okay, and LIGO, that is Laser Interferometer Gravitational Wave Observatory. No question on this yet, but India is planning to construct this. Okay, so this is there in the news, so you may expect question here also. Okay, so what is a black hole? Black hole something this is body in the space which does not allow any radiation to come out because of very high density. Okay, when the black hole is there in the space, there are not just one, there are many, and the gravitational influence is so high that one black hole may try to attract another black hole, and in this process what may happen, they may come closer and closer, and then this collision, okay, the merger will take place, and with this merger huge amount of this radiation which is known as gravitational waves. So it is like you throw a pebble in the water on a pond, so ripples they are formed. In the similar manner, these gravitational waves are formed. They travel several kilometers, several millions and billions kilometers in the space. Okay, in 2019 the merger of giant black hole had taken place, and because of which the gravitational waves were detected. Okay, in 2019 only the first photo of the black hole was taken. Okay, so 2019 it was basically current affair based question, but even if you do not know the current affair based aspects, the conceptual things will be helping you out. Okay, so out here I hope you have understood the solar system, and the probability of these questions that can come in the exams are mainly the conceptual based. Certainly it will be influenced by the current affair. Okay, so we should quickly move towards the second topic now, that is the geomorphology. So with respect to geomorphology, as we had initially seen in the analysis that not many question is being asked in prelims. It is an important topic, but from a mains perspective. So from the prelims perspective, let us see what were the questions that were asked so that we can focus accordingly. Here in geomorphology, we can see the question have been asked on the interior of the earth, and like very old question. Recently in 2023, last year itself, they had asked question related to earthquake, the P waves, S waves, okay, and the characteristic of the P and the S waves. And the third question is again with respect to what are the causes of the earthquake, then scales for the measurement of the earthquake, Richter scale, Mercalli scale. Okay, so we shall be covering all of these things. Now here the question in 2023, why this question was asked, it was actually there in the news last year in somewhere in February. There was a massive level of earthquake hitting the Turkey, and it was basically a very major earthquake. Okay, so it was because of this, it was there in the news. Okay, and this question was named. As such, geomorphology, there is no like major influence of current affair. We had already seen this question on magnetic field. We'll try to understand here. Solar storms, again this was bit in the news. Okay, very simple question. We have already heard of this term solar storm in the the solar system chapter. Here the question is with respect to effects of that. We have already seen some effects that it led to the reducing the earth atmospheric thickness. Here again a relatively similar question, 2012. Now with respect to the changes that is being brought upon the surface of the earth, so what are the factors responsible for that? And the magnetic field related question again. Volcanism related, they have asked in mains recently, okay, but prelims made quite old questions. Continental rift theory, okay. As such, these questions are basically mains oriented, not much asked in prelims, but once they had asked, okay, then to arrange the continents in the descending order of their size. Rocks related, they have asked question, very old questions, okay, and the gradation and weathering. So not many questions are there in from the geomorphology. So we should also be giving relevant focus to this topic. Now this is a very huge topic. Now it is safe enough that we should be doing the concept based topic first, and then some fact based topic can be taken care of. So here with respect to that of the evolution of the interior of the earth, we have already seen the evolution of the earth in general in the solar system. Here with respect to the evolution of the interior, earth, when the earth was created, it was quite hot, and over a period of time, due to the cooling, okay, the more denser material started sinking down, the less lighter material the started coming upwards, the gases came outside. In the interior of the earth, the denser material went inside, the lighter material went up, and in this way the different layers of the earth was created: crust, mantle, and the core. So this process of arrangement of this material in different layer is called as a differentiation process. Okay, with respect to the interior of the earth is 6,400 kilometer in terms of radius. Center of the earth is 6,400 kilometer from the surface. Now how do we get to know about the earth? So there are various direct sources, there are some indirect sources. Direct source: surface rocks, deep drilling, the volcanic eruptions. The deep drilling up to several kilometers is being done, but we cannot do the drilling infinitely till the like core. We do not have the technology for that basically, but there are several indirect sources, and they are basically like technology oriented. And these indirect sources, like analyzing the properties of matter, the meteor fall, the gravitation of that of the earth, the seismic activity, the magnetic field, all of these with the help of technology have given us a better understanding of the earth. Now here with respect to the interior of the earth, there was question asked on the interior of the earth, so we'll try to understand this quickly. Now from the surface of the earth, as you move in the interior, that the earth is divided into crust, mantle, and the core. But this understanding is basically the static model. Static model is basically based on chemical composition of the material. Okay, for example, crust is having ocean and the continent, and this ocean is made up of silicon, magnesium. Continent is made up of silicon and aluminium. Then the mantle is made up of ferrous and magnesium. Then the core is made up of nickel and ferrous. So it is basically the chemical composition model. Okay, now every time but this just chemical composition of the matter does not give us the entire picture about the interior of the earth. We need to go into more detail. Okay, we need to understand the physical properties also, and when we understand the physical properties, then the static model no longer remain useful. So on the basis of the physical property, there is this dynamic model which divides the earth into lithosphere, asthenosphere, mesosphere, endosphere. So here with respect to lithosphere has the property of it is very solid, and it is very brittle. It is elastic in nature. Elastic material are those which can regain the original shape after the release of the force. Plastic material are those which do not regain the original shape after releasing the force. So astronosphere is semi-solid in nature, roughly like it is plastic. Mesosphere is solid and quite rigid, and endosphere, the outer part of this endosphere is liquid in nature, and the inner part is solid in nature. Okay, now here the thickness of each of these layers is important. Crust is relatively 30-35 kilometer. In some books it is also written as 40. Okay, with respect to that of the ocean is very thin, roughly 5 kilometer in terms of thickness, and continent is 30 to 35 kilometer thick. Okay, then from 30 to 2900 kilometer is the mantle, 2900 to 6400 kilometer is the core. Okay, and with respect to lithosphere, it is 100 kilometer thick. Okay, asthenosphere is 100 to 600 kilometer thick, mesosphere is 600 to 2900, endosphere is 2900 to 6400. Okay, now as you go in the interior of the earth, temperature, pressure, density, all of these keeps on increasing. Temperature increases at the rate of 30 degrees Celsius per 1 kilometer. Okay, and when you go in the the surface of the atmosphere, like in the atmosphere, when it goes above, so from the surface, as you go in the interior, the temperature increases by 30 degrees per kilometer, and in the atmosphere, as you go up, the temperature decreases by 6.5 degree per kilometer. Okay, so try to know this values here. This have been asked by UPSC. Okay, so they may ask me this question also. Okay, so what we are doing is like we are deducing what question can come out of the analysis of previous year's question. The density of the material also keeps on increasing. The crust, mantle, and the core. The crust is having 2.7 to 3 grams per cubic centimeter density. Mantle have 4.5 roughly, and core is 10. So from the surface towards the interior, the density keeps on increasing. Pressure. Now pressure increases, but there is no uniformity. Okay, with respect to the increase in the pressure. Okay, now you can see some words in the red color. So these are the minor plates. Okay, these are the minor plates. So basically the crust, mantle, and the core, they are major plates. Then the crust, and the crust we see continent and the ocean. So between this continental plate and the oceanic plate, there is a minor plate known as canard. Okay, then between this crust and the upper mantle, there is this minor plate known as Mohave. Upper mantle, lower mantle, again minor plate Rapiti. Then the lower mantle and the outer core, Gutenberg. Outer core, inner core, Lehmann. So just try to mug up this fact in the order. UPSC may ask the order in this. Okay, so I hope the static model, the dynamic model, the major plates, minor plates, and the some important physical properties is understood to you. Now this is what we have just seen. Now with respect to that of the seismic waves, seismic wave is very important. 2023, this was the question. Seismic wave will understand what is the types, shadow zones, the earthquake, causes and effects, measurement of earthquake, and distribution of the earthquake. So with respect to that of the seismic waves. So what is seismic waves? This is basically the the waves that is released because of the release of the energy. The waves that is formed because of the release of the energy. Okay, somewhere in the interior of the earth, and this wave causes shaking of the earth, and the effect of this seismic wave is earthquake. Okay, so now why this wave is being released? What are the causes of this seismic activity? So it is basically the movement, the plates. The plates may be moving because of volcanism, volcanic eruption, if it is very violent in nature. Then meteorite impact, landslide. See, landslide may cause seismic wave. Seismic wave may cause landslide. So it is both the way. Volcanism may cause seismic wave. Seismic wave may also cause volcanism. Okay. So these are some important causes. UPSC asked question on causes of earthquake. Okay. So seismic wave. So somewhere deep inside, see this. We have just seen asthenosphere. So asthenosphere is partially molten or semi-solid in nature, semi-liquid in nature. So these magma, when they magma is hot hot thing rises upwards. When they rises upward, above that is the lithosphere. Above asthenosphere is lithosphere. So when the magma rises upward, it will be pushing the lithosphere from below. Okay, so it will be causing a lot of stress over here. So it will be pushing from below and it will try to diverge it. Okay, the magma will fall down and it will try to diverge the plate over here. Okay, so where the plate is converging, the magma is sinking downward, the plate might be converging. The magma rising upward, the plates might be diverging. So because of this, we would have some divergent plate boundaries. At some place the plates will be converging, so convergent plate boundaries. So it is basically these magma that assist in the movement of these plates. When the plates are moving, so since Earth is a sphere, so when it is moving away from one place, so at some other place it is going to converge. When this plate is converging, so certainly there would be like frictions, okay, and there will be like accumulation of the energy, and when then this energy is released, it will cause seismicity. Okay, so the point from where this seismic wave start is called as the focus or the hypocenter. And when these waves that is in the interior of the Earth, so these waves are called as a body waves. Okay, these are called as a body waves. When these waves reach the surface of the Earth, so again the seismicity would continue on the surface. Those are surface waves. Body waves, when they are of two types, basically body waves when it is the original one. Okay, when it's starting from the hypocenter, okay, or the focus point, that is known as primary waves. When this primary wave hits a solid or hard object within the Earth, from there the another set of waves will start emerging out. Those are known as the secondary waves. So body waves are two types: primary waves, secondary waves. And surface waves are also two types, that is the love wave and the relic wave. The point on the surface of the Earth which is nearest to that of the hypocenter, or just above that of the hypocenter, that is the epicenter. So whenever earthquake is there in the news, the very first thing that they will mention is where is the epicenter. Okay, 2015 Nepal earthquake was there in the news, and there was a mains question, okay, related to Nepal earthquake. 2023 Turkey earthquake was there in the news, and it was a prelims question. So you can expect question whenever it is there in the news, especially when it is major one, because minor earthquake happens almost every day. Types of waves: body waves and the surface waves. So body waves we have just understood are of two types, primary and secondary. Surface wave two types, love and relic. Now there was a question on this latitudinal waves and the longitudinal waves, so you must focus over here. So body waves are longitudinal waves and the rest of the waves are transverse waves. So what is the difference between longitudinal waves and the transverse wave? So just quickly a quick understanding that that in the case of transverse wave, first focus on the transverse wave. The transverse wave, the vibration is up and down, and the movement of the wave is perpendicular to the vibration. Okay, the movement of the wave is one direction and the vibration is perpendicular. So just like when you like just wave a cloth or a bed sheet, so the vibration is up and down and the movement of the wave is like horizontal. So this perpendicular type of waves, okay, so that is known as a transverse wave. Transverse wave passes through solid medium only. Okay, longitudinal waves on the other hand, the vibration and the movement is parallel to each other. Vibration and movement is parallel to each other. So contraction, relaxation, contraction, relaxation, contraction, relaxation. So here in this case it is parallel to each other. Now when the waves is passing, so certainly the density of the material will change. Earlier let us say the density is so and so for the material, and later on it may be dense at one place and rare at some other place, so density may change. Okay, longitudinal waves passes through solid and fluid, that is passes through solid and liquid both. Okay, I hope you have understood this. So now just try to understand that P waves are longitudinal waves, rest other are transverse waves. Okay, P waves passes at the speed of 7 to 8 km per second, and this is at the speed of 3 to 4 km, 2.5 and 2.5 km per second. You see the direction of the movement, it is like contraction, relaxation, contraction, relaxation. This is up and down, and this is surface. So surface may it will not go up may it is air. So on the surface it is going to move left and left right like a snake, so serpentine movement. And lastly, the relic wave is cyclic in nature. You know, the surface goes below, the below material comes up, so it is cyclic. So this is very very devastating. Okay, very devastating. So fastest one is primary wave, the most devastating one is the relic wave. So on the seismograph, it is the instrument used for the measurement of the earthquake. The first wave that is noted is primary waves, that will be followed by secondary waves, that will be followed by surface wave. And on the surface it may be love or relic, any. Okay, so let us proceed ahead with the shadow zones. Okay, having completed shadow zone, we'll proceed ahead with the questions. Now, shadow zones. So consider Earth and you consider a focus point, and from there primary waves is starting. What did we study about the primary wave? That is the body waves only. Primary waves is longitudinal waves, passes through solid and liquid both. Okay, solid and liquid both. So so when the density of the material is constant or the similar, so the waves is going to spread out in each direction. But as it comes to the outer core we had seen it is liquid in nature, yes or no? So it will pass through liquid also, solid and liquid also, but what happens is two different density, solid, liquid, two different densities. So when the density changes, the wave do not travel in the straight line, it will bend a little. Okay, so this is a property of refraction. So when the medium is different, when the density of the medium is different, and when the wave is passing, it will not travel in the straight line, it will bend. Okay, this is refraction. Okay, so here the similar thing will happen, it will keep on bending, and ultimately what will happen is from the focus point or the hypocenter till 105 degree on the other side, it can be observed. From 105 to 145, okay, it can the primary waves is not noticed. Again from 145 to another 145 it can be noticed. If it is 0 over here, it is 90 over here, somewhere at here is 180 degree longitude. So this zone is known as the shadow zone of the primary waves. In the similar manner, shadow zone of secondary waves is transverse. Transverse passes only through the solid, not through the liquid. So here in this case it will not enter this outer core which is liquid in nature, so it will remain confined from 0 to 105, 0 to 105 only, and such a big shadow zone of secondary waves can be noticed. Okay, so so here UPSC may ask question, shadow zone of which wave is bigger? Secondary waves is bigger. Okay, so proceeding ahead with respect to that of the earthquake. So there are several reasons for the for the earthquake. It can be plate movement or the volcanic eruption. For example, in 2021 the volcanic eruption in the Tonga, which is in the Pacific Ocean, led to the earthquake, and because of the earthquake the coastal flooding, tsunami had come. Okay, tsunami had come, and this was a mains question. Okay, so here we it can be asked in the prelims also. Okay, whenever these are there in the news. So folding or faulting of the plates or the landslides or meteorite impact can cause man-made hazards like the deep underground mining or the nuclear explosion, or even the reservoir induced seismicity may cause the earthquake. Reservoir induced seismicity is basically when the reservoir is there, if you're having huge amount of the waters. So this is having a very high potential energy, right? So when this suddenly the water is released, so potential energy is converted into kinetic energy, and huge volume of the water falling on the ground, so it will cause a seismicity or shaking of the the surface in the localized region. It is not going to be a very very high magnitude earthquake. Localized seismicity. For example, the Koyna river in Maharashtra. Koyna river in Maharashtra is quite known for this reservoir induced seismicity. Okay, let us proceed ahead now. What are the effects of the earthquake? Shaking of the ground and the rupture of the ground may take place. The cracks may happen. The landslide and avalanche may take place. For example, in 2016, the avalanche in the Siachen Glacier took place. 2022 landslide in Chamoli, took place. 2016. Also, the northeast may, like the landslide was had taken a toll of many people, and this is increasing. Like in northeast, because of deforestation, because of seismic activity, landslides have increased. Okay, then the earthquake can also cause wildfires. Yes, the rubbing of the trees, dry trees, especially in the summers, may cause big forest fire. For example, in 1906 San Francisco, forest fire was because of this earthquake only. Soil liquefaction, basically soil which is saturated with the water will form more of liquid in nature. And let us say you have a house, and below your house the soil, which was hard, solid, and was holding the pillars, let us say it became liquid. Okay, so what will happen? The pillars of the structure will become very, very weak. It will lead to the collapse of the structure also. Okay. Earthquake also caused tsunami. In 2011, earthquake caused a tsunami in Japan, in Tohoku. Okay, and because of this tsunami in Japan, there was this nuclear reactor, Fukushima. So a crack had happened in that nuclear reactor, and it became a cause of concern, because the people were fearing that the nuclear disaster may happen, just like Chernobyl nuclear disaster. So it may also cause flood. Okay, for example, the river may change the course, or there may be collapse of the dam, or GLOF. GLOF is glacial lake outburst flood. Those lake which is formed because of melting of glacier water. Okay, so when the earthquake happens, that the glacier may slide and it may fall in the lake, and that lake water may spill out, and it may cause flooding. So that is glacial lake outburst flood. Glacial lake outburst flood have increased in the recent years because of global warming. Global warming is causing faster melting of the glacier, and also the avalanche. Earthquake. In the seismograph, the earthquake is followed in this way. First, primary waves, followed by the secondary waves, followed by the surface waves. There are basically two scale. One is the Richter scale, okay, which is used for the measurement of the magnitude. Richter scale is a base 10 logarithmic scale. Means every integer indicates 10 times more shaking. Okay, each integer indicates 10 times more shaking. For example, let us say 5 magnitude earthquake. So 5 magnitude earthquake led to release of the energy, and it caused the shaking of the earth. And let us say next year it was the 6 magnitude earthquake. So this will be 10 times more dangerous than that of 5 magnitude earthquake. Let us say subsequent year 7 magnitude earthquake came. So it will be 10 times more than that of 6. And it will be 10 into 10. That is 100 times more than that of 5 magnitude earthquake. So just one integer is 10 times more dangerous. Okay. Now, with respect to that of the energy, energy released by is like 31.6 time in each factor. So for example, let us say when it was 5 magnitude earthquake, m amount of energy was released. When it is 6 magnitude earthquake, 31.6 times of this amount of energy will be released. When it is 7 magnitude earthquake, 31.6 time of 6 of this. And if I am comparing with this 5.1 to 31.6 into 31.6, that will be roughly 1000 times energy. Okay, so a 2 integer factor. So if it is like a 2 integer factor, it will be like 1000 time of energy released. Okay, and when it comes to the shaking or the disaster, when it is 10 times more. Okay, then for example In 2004, in the case of the Indian Ocean, 9.4 magnitude earthquake, one of the biggest earthquake. 1916 Valdivia, earthquake of Chile. In South America, 9.5 magnitude earthquake. This is the largest earthquake so far. Now, Richter scale had some problems. Like, for example, very high magnitude earthquake, it was not able to give a very precise information. So this Richter scale, which is a magnitude scale, was later on modified. Okay, it was modified, and some modification, some upgradation was being done, and later on termed as moment magnitude scale. Richter scale had problems like it was not able to give accurate data, and not unable to predict record properly beyond 600 kilometer depth, and large scale earthquake, it was not very much reliable. So 1970s we shifted from the Richter scale to that of the moment magnitude scale, or MMS. India uses this scale. Okay, so whatever was the limitation of Richter scale was overcome by this MMS. Okay, usually used in the developing countries. Some of the developed country also uses it. There is no upper limit in moment magnitude scale. For example, this Richter scale had the range of this was 1 to 10. Here in this case there is no upper limit. Okay, there is no upper limit in the moment magnitude scale. Now, with respect to this Mercalli scale basically measures the intensity. Intensity basically the effect. What is the effect? Whatever is the amount of magnitude of the earthquake, the impact may be different for the different region. Let us say some region is very well developed, so when and some region may not be well developed, so same magnitude earthquake will have different amount of effect on each of these region. So some countries, especially the developed countries, they thought that they should be measuring the earthquake impact in terms of the earthquake in terms of the impact that it is causing. So Mercalli scale was introduced, which was also upgraded in 1931, and modified Mercalli scale or modified Mercalli intensity scale was termed. Now it is ranging from 1 to 12, usually used in the developed countries. India uses what? India uses MMS, okay, moment magnitude scale. With respect to the earthquake, so earthquake mainly happens in this region, the alpine belt or the mid-continental belt, where the plates is either, here the plates are converging, and in this ring of fire, also known as the circum-Pacific belt. So these are those regions where earthquake mainly happens. In the case of the India, it is the Himalayan region where the very high seismicity earthquake can be expected. Okay, when it comes to India, so in India, where do the earthquake is more prominent? So most part of the India is prone to some or the other form of the hazard. Okay, so here in the case of India, the northeastern part is zone 5, which is very high seismic region. Okay, also the Kutch region is also very high seismic zone, followed by that of the zone 4, which is relatively less intense. Okay, Delhi also falls in this zone only. Okay, now for that purpose, in those regions, very high tall story buildings usually are not allowed. Okay, and in the recent construction, it is mandatory to use the earthquake resilient infrastructure. Okay, then there are certain reasons where zone 3, zone 2, so there is no zone 1. It means no part of India is 100% free from earthquakes. Every part of the India is like having some form of, is prone to some form of the earthquake. Okay, now with respect to that of some of the questions we can solve here with respect to that of the interior of the earth. So in the structure of the planet Earth, below the mantle, core is mainly made up of. So we have seen that in the crust, mantle and the core is mainly made up of nickel and ferrous. Okay, nickel and ferrous, and of nickel and ferrous is more. So answer is iron over here. With respect to that of the earthquake, the question is, consider the following statement. Here the question is very, very important, very useful also. You may try and attempt this question. So here the question is a very current affair based question, but conceptual question. It says, in a seismograph, P waves are recorded earlier than S waves. Very true. Second statement says P waves, the individual particles vibrate to and fro. So P waves, we have seen that it is a longitudinal waves. Yes, P waves are longitudinal waves and S waves are transverse waves. So transverse wave may the particles move up and down and then move ahead, and P waves may it is like to fro. Okay, P waves, individual particles vibrate to fro in the direction of the wave propagation, whereas in S waves the particle vibrate up and down in the right angle to the direction of the wave propagation. Very simple, easy question. Here the question is with respect to the causes of the earthquake. What are the causes of the earthquake? The development of fault, movement along the fault, impact produced by volcanic eruption, folding of the rocks. All of these will cause earthquake. Here question number 4 is very nice. Question number 4 and 5. It says the Richter scale is logarithmic scale, and so an increase of 1 magnitude unit represents a factor of 10 times in amplitude. True? 10 times in terms of the amplitude. But second statement, see, each integer reading of Richter scale has energy of 100 times that of the previous reading. It says previous reading. So it is 31.6 times. Energy wise, 31.6 times. I hope you remember that. Okay, it is not 100 times. This is wrong. Next question. The intensity of earthquake is measured in Mercalli scale. Yes, intensity or effect or impact. And second statement, magnitude of earthquake is a measure of energy released. So magnitude of the earthquake is energy and intensity is Mercalli scale. This is correct. Okay. Now statement 3, earthquake magnitude are based on direct measurement of amplitude of seismic wave. Magnitude is direct measurement of amplitude of seismic wave. This is also fine. Now look at the fourth statement. In the Richter scale, each whole number demonstrates 100-fold increase in the amount of energy. So it is not 100-fold increase in the energy, it is 31.6. So here the mistake in statement 4 is same as the mistake in statement 2. So repeated kind of question. So you may expect repeated questions. Yes, there are repeated questions. This is purely current affair based. Okay, we can proceed ahead with the subsequent topic now. With respect to the continental drift theory, so everyone is aware about this continental drift theory. This was the theory, first theory, which was postulated to explain how this continent was formed. So basically, Alfred Wegener, okay, way back in 1912, came up with this theory. Okay, according to him, that Earth, what it looks today, is not what it was there in the past. Okay, so Earth was initially, as per him, Earth was having only one continent, and this continent was known as the Pangaea. Okay, and roughly like more than 360 million years, that is pre-Carboniferous period, Earth was one continent known as Pangaea, and it has one ocean, that was Panthalassa. Over a period of time, because of two forces, roughly between the Carboniferous period 286 to 360 million years, the Earth split up in terms of their the continent. The Pangaea got split up, leading to the formation of the Angara land, also known as Laurasia, and the Gondwana land. And there was a sea that opened up in between, that was known as the Tethys Sea. Today, Tethys Sea is also closed. Okay. And in the subsequent stage, in the third stage, that is post the 300 and post this stage, that is roughly in the Cretaceous period, 65 to 145 million years from the present, what it said that further splitting of these continents took place. The Angara land from North America and the Eurasia, and the Gondwana land from South America, Africa, Antarctica. Okay, and ultimately we have this planet today with several major continents. What he further says that this is further, that North and South America is further moving westward, and further opening of the expansion of the oceans is taking place. Okay, his theory was a little bit of criticized, and later on it was appreciated also because of coming up with the theory for the first time. So it was criticized because the forces, he said, the forces, it said that the rotation of the earth and the gravitational pull of the moon and the sun. So these forces, what he had mentioned was responsible for this to happen, those forces were criticized because these forces are not responsible. Yes, the drifting of all of these continents have taken place, formation have taken place, okay, but these were not the reason. There were some other reasons. Okay, so the main reason was basically the slab pull, which was basically due to the gravity of that of the earth itself, okay, assisted by several other forces like the magma from the astrosphere. Okay, that was the assisting force. Now he gave us several theory evidences in support of this. Those are not very important from the prelims, but this is important. This is there in the news. You may expect question related to this. Zealandia. So we have 7 major continents. What are these 7 major continents? It is important that you should be knowing all of them in the descending order. So these are the North America, South America, okay, then Africa, Eurasia, that is Europe and Asia, Indo-Australia, Pacific, and Antarctica. These are 7 major continents, and Zealandia is considered as the 8th continent. It is 1 to 2 kilometers deep in the South Pacific Ocean, and it is a part of Rodinia supercontinent. Okay, intermediate supercontinent, that is Rodinia, roughly 4.5 or 5 million, 4.9 or 5 million square kilometer, and most of it is there in the water. Okay, so it's there in the news. You may expect a question related to this. Now the question may also come like, for the surface plate to be declared as a continent, what is the factors or what are the criteria? Okay, so like for example, for a celestial body to be declared as a planet, you cannot just declare anything in the space as a planet. Planet is a status given to a celestial body because it is fulfilling certain criteria. So what are those criteria? So planet must have a strong gravitational influence, must have its path cleared, and must follow in the same orbital plane as that of the other planets. These criteria was not fulfilled by Pluto. Okay, so for that purpose, Pluto was removed from the list of the planet. And earlier, why was it included in the planet list? Because this criteria was formed later on. Okay, later on, and 2006. Okay, so in a similar manner, criteria for a continent. So it must have a distinct geology. It must have a very well defined area, and it must the crust must be relatively thick. Because we know that there is like continent and there is the oceanic place, so crust must be relatively thicker, especially the continental part. Okay, the elevation must be above the surrounding area. It must not be very much submerged. Okay, then because then it will be a plate, but it will be like an oceanic plate, not the continent. Then the area must be greater than 1 million square kilometer, must not be connected to other continents. Okay, there might be bordering, there might be convergent divergent plates, okay, but must not be connected to other continents. So this criteria or this one, definitely it is expected that it should be asked. Okay, so just memorize this. Well defined geology, in a well defined area, distinct geology, crust must be thicker than the ocean, elevation must be above the surrounding area, 1 million square kilometer ka area, and must not be connected to other continents. Okay, let us proceed ahead now. Now with respect to the other theories, for the better understanding of how the earth, the continents and different plates were formed, convection current theory was given later on, which said that magma, which is in the astrosphere, that is causing this movement of the plates and formation of the continents, which was again later on not very well appreciated. Okay, because it also had certain limitations. Okay, so now what was mainly accepted theory was the plate tectonic theory. Okay, the plate tectonics. So in terms of the plate tectonics, what does it say? That the plate is the moving, and this movement is mainly because of the gravity. Gravity pulls the heavier object toward itself, and we know that on the crust there is oceanic plate, there is continental plate. Continental plate, we have seen that it is relatively lighter as compared to oceanic plate. Oceanic plate is more denser. So when the two plates is coming towards each other, certainly the denser plate is going to go down. So oceanic plate is going to go down, and this going down is because of gravitational pull. Okay, gravitational pull. So this entire slab, it goes down, and because of it going down, as it is going down, the interior of the earth temperature increases, so melting of this plate will take place. This magma which is formed will come up somewhere. Okay, so usually it will come out on the continent side, leading to the formation of the volcanic mountains. Okay, so there is like several other associated things with this plate tectonic. Let us understand them. So these are some major plates. Okay, 7 major plates. The 8th one, Zealandia. Okay, there are several minor plates also. UPSC will ask a question like which is a major plate or which is a minor plate, or it may ask question with respect to the oceans or the regions, and they will ask the name of the plates. Okay, recently they had asked question on Anatolian plate. Turkey is basically located on this Anatolian plate. Okay, so this Nubian plate, Somalian plate is very much there in the news, and it is there in the news because you must have heard that Africa is splitting apart. The Great African Rift Valley, from where the Africa is splitting apart, and it is basically the Somalian plate which is cutting out from the Nubian plate. Okay, so we must be knowing the relative location of these plates. Okay, Juan de Fuca, Cocos, Caribbean, okay, the Arabian plates or the Philippine plates, etc. These are just few, but these are the important ones. Try to memorize most of them. Okay, now with respect to the plate movements, the plate may either come towards each other, or it may move away from each other, or just slide past each other. Okay, so when the plate is coming towards each other, that is the convergent plate boundary, and some phenomena happens in this convergent plate boundary. Now there is 3 subcategories within this. The plate may be one continental plate, one oceanic plate, or 2 oceanic plate, or continental plate, and different landforms are formed. Okay, there are many prelims question on this. Okay, so when the continent and the ocean plate is coming, so we know ocean plate is more denser as compared to continental plate. So when they two are coming, so oceanic plate is going to sink down. Okay, the oceanic plate is going to sink down, and when it is sinking down, it is going in the interior of the earth. In the interior of the earth, it is more hotter, so oceanic plate is going to melt, and this magma, the molten magma, will rise up, okay, on the other side of the continent, okay, giving rise to volcanic mountains. So here the continental plate is relatively lighter. Okay, so let us say this is the continental plate, this is oceanic plate. When the two are coming towards each other, so oceanic plate is very strong. Oceanic plate is very, very strong. So nothing will happen to it. It will not fall, it will not bend. It will just straight away go, and it will go and melt. But what will happen to the continental plate? Continental plate will keep folding because it is relatively lighter. Okay, so it will fold, it will bend. Okay, and this bending will lead to the formation of this mountains, that is the fold mountains. These fold mountains may be volcanic, or at times some of them may not be volcanic in nature. Okay, so fold mountains can be formed because of the convergence of a continent and oceanic plate. These mountains may be volcanic in nature, and here a valley in the ocean side at the convergence of these two plates. This valley is known as a trench. it is a deep, narrow, steep valley known as a trench. So trench in the oceanic side, and Benioff zone. So here it would be that zone where a very high friction between these two plates is taking place. So this is the Benioff zone. Okay, zone of subduction, the oceanic plate is subducting down. So for example, Rockies and Andes mountain range, if you take, so here in this case you consider the Rocky Mountains. Here let us consider the Rocky Mountains. So Rocky Mountain range is formed because of convergence of Pacific plate and North American plate, Pacific plate and the North American plate. Okay, Rocky Fold Mountains. Similarly, the Andes Fold Mountain because of convergence of the Pacific plate and the South American plate. Okay, now the UPSC won't be asking question on the theories related to plate tectonic, but they will be asking prelims questions related to the mapping part especially. Okay, let us proceed ahead quickly. Ocean convergence. When two oceanic plates is converging, now both are denser. Okay, both are denser. Okay, so one of the two which is heavy, okay, will go down, sinking will be taking place. Okay, melting will be happening as it is going down, and this molten magma will rise up in the form of the volcanisms. So this island arc will be formed, also known as the archipelagos. Okay, so there are many examples of that. For example, this Aleutian mountain in Japan, Andaman Nicobar, this Indonesia, Malaysia, Philippines, these are very good examples of ocean convergence. Now continent convergence. Now both are relatively lighter, so what will happen when two lighter plate is converging? So it will be the zone of abduction, it will be rising upwards, Fold mountain will be there, but will it be volcanic? No volcanism. Okay, no volcanism. So for example, the Himalayas, okay, the Alps mountain range, okay, Himalayas and the Alps. So Himalayas formed because of the convergence of the Indian plate, okay, and the Eurasian plate. Okay, Himalayas is fold mountain, but it is not volcanic in nature. Now example of the overall example of the convergent and the divergent. So in the Pacific region, at some places the convergence is taking place, some places divergence is taking place, but majority convergence is there. Okay, so in this entire region, this fold mountains or the island arc, these are also associated with earthquake and volcanism. Okay, so this region is known as the ring of fire. UPSC had asked question in mains related to the geophysical characteristic of circumpacific zone. Okay, so now divergent plate boundary. Diverge, plate is moving away from each other. So this will happen like within the plate will diverge. So crack will take place first. The crack will take place. Okay, so this crack, this is known as, this valley that is created is known as a rift valley. Okay, when this crack opens up, so the water from the adjoining sea may enter this, and it will lead to the formation of a narrow sea. And when the further divergence takes place, so it will form an ocean, okay, leading to the formation of a new oceanic plate. So earlier there is only continental plate. Now you can see continental plate have moved away and ocean have opened up, leading to the formation of the oceanic plate. Okay, so in the initial stage, the plates is drifting apart and a rift valley will be created. For example, East and West African rift valley. Okay, so here in this case you can see, for example, the Somalian plate and this Nubian plate. So here the divergence is taking place. In future, what may happen? It will crack further, and water from this Indian Ocean region will enter into this, and it will lead to the formation of a new sea. New sea will be formed over here. Okay, and further what will happen is it will further completely split apart, leading to the formation of a big ocean over here. Okay, so in the subsequent stage, what we have seen is opening of the sea, for example, Red Sea, and subsequent stage, sea floor spreading will take place. For example, the mid-oceanic ridge. The mid-Atlantic ridge is a classic example. This is the Atlantic Ocean, and you can see, so earlier it was like one continent, then split apart, and then the narrow sea was opened, and subsequently it widened up, leading to the formation of an oceanic plates have come up, and it is further expanding, which means Atlantic Ocean in future is going to become the biggest ocean. Okay, and this is what you can see. These are the mid-oceanic range. These are like mountains, long range of mountains in the ocean. Transform fault boundary. So these are those plates which is moving, sliding past each other. So convergent plate boundary, divergent plate boundary, and those plates which is sliding past each other. So there will be no mountain formation taking place. Okay, there is no folding taking place, but yes, friction is there. So accumulation of energy will be there, and it will lead to the very high seismicity earthquake. No volcanism, very high seismicity earthquake. For example, this San Andreas fault in San Francisco, okay, California. Also Anatolian plate. So Anatolian plate is like basically having this North Anatolian fault and the East Anatolian fault, and they are also sliding past each other. So it is basically in this region. In last year, a very high seismicity earthquake had taken place. So in those transformed fault region, very high seismicity and huge destruction can happen. Okay. So movements of the Indian plate, how this Indian plate moved. You can see this is basically the movement of the Indian plate in this order. So India was part of the Gondwana land, and roughly 70 million years ago from the present, the movement started, and roughly we hit the Eurasian plate somewhere around 10 million years. Okay, so now this movement, as India moved over the this region, so there was initially a sea. That was known as the Tethys Sea. That was there, that got closed. So when two continents merge, so before two continents there is an ocean. So basically a continent convergence is preceded by a continent and ocean convergence, and ultimately the ocean plate completely get destroyed, and then two continent convergence continue. Okay, and then the fold mountains and all takes place. So here in this case, India was part of this Gondwana land, and it split it apart, and roughly 70 million years it started its northwards movement. Initially there was a sea known as the Tethys Sea, which got closed. Now there was a hotspot. So this hotspot is basically the region from where the magma was rising upward. So as India moved over it, this magma also oozed out on the Indian plate, and it formed one layer. In fact, multiple layer by layer was accumulated over the India, and this have led to the formation of the Deccan Plateau that we have today. Okay, so Deccan Plateau, that was roughly 60 million years. It was formed much before the formation of the Himalayas. Okay, then roughly 40 million years we just touched the Eurasian plate, and Tibet was already there. Then we already had this Deccan Plateau over us, and then the convergence of two continental plates took place, and then the formation of the Himalayas. Okay, so I hope things are getting easier for you to understand. Now they won't be asking many questions on theories. Certainly those are mains related one, but having completed the main syllabus, it is certainly going to assist you in the prelims. Okay, also it is important that you should be knowing the concept, because concept based question, irrespective of the syllabus, they will ask in prelims also. Some fact based information should also be known. If there is a lot of facts, try to know the trend of the facts. Okay. here with respect to the minerals and the rocks in detail, we are going to understand mineral in the mineral chapter, but over here with respect to that of the earth crust. So earth crust, we saw it had the continent and the ocean. So continent was silicon and aluminum, and the ocean was silicon and magnesium. I hope you remember that. So basically many student thinks that silicon is there in the continent, silicon is there in the ocean also, so silicon would be highest, but that is wrong. On the earth crust, oxygen is highest because all of these silicon, aluminum, magnesium are in the oxide form, silicon oxide, aluminum oxide, magnesium oxide. So it is basically oxygen which is highest in earth crust. Okay, but if you take whole of the earth, iron is the most abundant element. If you take the interior, for example the core again iron is maximum. So crust mein oxygen is maximum, core mein iron is maximum, overall earth mein iron is maximum, oxygen is second. Okay. I hope these things are getting clear to you all. Rocks, UPSC was 2 questions on rocks. In last 20 years only 2 questions, so not very important topic, but you should be knowing some basic characteristic about these rocks. Igneous rocks, we are basically the igneous rock which is the parent rock, and from there all the other rocks formation have taken place, sedimentary or the metamorphic rock. So here igneous rock, it is the parent rock, also known as a primary rock. Igneous rock is basically the magma that is rising from below. Some of the magma may get trapped inside itself, solidify itself, that is intrusive igneous rock. Some of the magma may come outside on the surface and then solidify, leading to formation of rock known as extrusive igneous rock. So extrusive igneous rock or intrusive, the common characteristic is they don't have any layers, layer by layer formation do not take place. They are mainly in the form of crystals. Okay, they are massive, they are hard, they are compact, and they are free from fossils, no fossil. Okay, they may be dark or light in color. Extrusive igneous rock, also known as a volcanic rock, they're fine grained, they are hard, and they are colored, and when they form soil, they will form black soil. Okay, black soil is very, very important, okay, for the cotton cultivation. Intrusive igneous rock, so intrusive igneous rock is basically the coarse grain, and they are basically condensing beneath the surface of the earth. So it can be the granite, dolerite, etc. And extrusive mein it is basalt, which is very, very important. So some features should be just kept in mind. Sedimentary rock is more important. Sedimentary rock, sediments. So sediments have led to the formation of this rock. So the intermediate stage from one rock to the another rock, especially from any rock, you take igneous rock or a metamorphic rock. So when these rock form sedimentary rocks, so initially these rock have to be broken down, leads to the formation of the sediments. Then sediments over a period of time will coalesce to form the sedimentary rocks. So sedimentary rocks, this process of formation of sedimentary rock is known as lithification. So sedimentary rocks are basically layered. Okay, they may have the dead remains of plants and animals, so basically they will have fossils. Okay, they are stratified. Okay, and when they will form soil, they will form alluvial soil. They contain some minerals like iron, coal, petroleum. Examples like lowest still, or these are important: sandstone, limestone, shale. Okay, chert, potash, gestite, chalk, etc. Okay, you do not need to memorize these, just memorize some of the examples and features of each of these rocks. Metamorphic rock. Metamorphic rock are the one which is formed because of extreme heat and pressure, not melting. When it is melted, it will form, like after solidification, it will form igneous rock. So over here in the case of metamorphic rock, it is formed because of heating or pressure. When it is formed because of excessive pressure, so what happens is, you consider this is one rock, this is another rock, you consider the crystals of this rock. So when it is like forced to forced to merge, okay, when excess of pressure is applied, certainly the crystals will like merge, it will interlock, and these interlocked crystals will form very hard rocks. So these rocks are basically very hard, okay, very hard, very strong, and they are formed under intense pressure and temperature. So when it is formed because under the influence of pressure, it's known as dynamic metamorphism. For example, granite will form gneiss. Granite is igneous rock. Clay and shale, which is sedimentary rock, under pressure it will form schist. Okay, when it is formed because of thermal metamorphism, temperature, known as thermal metamorphism. Okay, for example, sandstone, which is a sedimentary rock, under heat it will form quartzite. Clay and shale will form a slate. Coal will form anthracite and graphite. Okay, so these are of great economic importance, because important minerals like gems, ruby, sapphire, all of these are formed in the metamorphic rock only. Okay, so just few characteristics and some examples. Okay, that should be sufficient. You may solve these questions, okay, because these are quite simple and well-to-do questions. Here you may expect just one question from this geomorphic process, not many questions, just one, maximum 1 or 0. This is very useful, very important, but not from prelims. In the last couple of years, it was seen just 1 or 2 questions have been asked, but the UPSC may ask question related to the mountains, especially the mapping part. Okay, especially the mapping part. So basically the landforms basically we have mountain, plateau, plains. Plateaus and plains, but they don't ask, so we'll not focus here. We'll focus on the mountain, especially the mapping part. So mountains are of two types, structural and volcanic. Structural mountains are fold and fault mountain, also known as block or fracture mountain, then the volcanic one. We have just understood fold mountains. Fold mountains is formed because of convergence of the plates. Okay, it can be either 2 continental plate, or it can be 1 continent and 1 oceanic plate. Okay, fold mountains are usually taller. Okay, but fold mountain is also under the action of erosion. So fold mountains maybe, which is formed relatively recently, are young fold mountains. Some mountains are quite old, so old fold mountains. Okay, so Himalaya, Alps, Rockies, Andes, these are young fold mountains. Appalachian, Ural, and the Aravalli are quite old fold mountains. These are some important examples of the fold mountains of the world. You should memorize most of these fold mountains. We have just seen Rockies, we have seen Andes, Alps, we have seen Himalayas. There are other fold mountains also that you should be knowing, especially the location. Okay, fault mountains. Now fault, they are also known as the block mountains. So these mountains are formed when the 2 blocks come towards each other. The middle block may rise up, or when the 2 blocks move away, the middle block may fall down. Okay, so leading to the formation of mountain and valleys. Okay, that is the graben. Okay, graben. So graben is basically the valley. Okay, and the host is basically the mountainous part, elevated part. Volcanic mountains is more important, and there was prelim mains question both over here. So what should you focus on the volcanic mountain is types of lava and this types of volcanic mountain. Only these 2 would be sufficient. This will be like basic plus some mapping. Okay, so we have seen the volcanic mountains. Volcanic mountain is because of the magma volcanism, and this magma, where do we get to see? Is those regions where there is at least 1 oceanic plate. So it is formed where the continent and oceanic plate convergence, and also ocean convergence. Now volcanic mountains can also be seen in those regions where there is volcanic hotspot. Okay, so here in the case of lava, there are 2 types. One is andesitic or acidic or composite or stratovolcanic lava. So these lava are very viscous, very thick. Okay, they have very high melting point. They're very thick, so they flow slowly. Okay, and they solidify very rapidly. Okay, so when when the magma will come out, it will come out solidify, it will not travel much distance. So layer by layer by new magma layer will keep on piling up one above the other, and ultimately it will lead to the formation of the taller volcanic mountains, which is layered by layered. Okay, so it is also known as stratovolcanic, composite, or acidic in nature. Now the acidic have a very high percentage of silica. Okay, high percentage of silica. Second one is basic or basaltic या फिर shield lava. So they are basically more hotter, they are more fluid in nature, they have more concentration of iron and magnesium, less silica. Okay, so they are more fluid, so they will be covering longer distance. Okay, covering longer distance, which means they will not be piling up one above the other. Okay, so it won't be very tall, but it will be broad enough. So those volcanic mountains formed because of this basic or basaltic lava will be quite broad enough, okay, but relatively short. Okay, so these are the shield volcanic mountains, and these volcanic mountains would be relatively less broader but more taller in nature. Okay, so these are the composite volcanic mountains. And next is the classification of volcanic mountains on the basis of activity. There are some volcanic mountains which is active, very active. Okay, and they're constantly exploding. For example, Barren Island. There was prelims question on Barren Island in 2018. Okay, this is the only volcanic mountain of India. Okay, and in 2018 it became active. It was active, but for many years the explosion had not taken place. Then the Stromboli in Italy is called as the lighthouse of the Mediterranean because it is very explosive in nature. There are some volcanic mountain which is dormant or sleeping. Okay, and in future it may, like anytime it may explode. They're not constantly active. And extant volcanic mountains, these are the one which have not erupted down in several years. Okay, so volcanic mountains are basically majorly like three types: shields, composite, and the cinder cone. So shield volcanic mountain, we just saw that these are those volcanic mountains which is relatively broad enough, okay, but relatively shorter. So it is formed mainly because of basic lava. Okay, then the cinder cone volcanic mountains are those one wherein the vent, it forms like cone like the structure. So usually when the eruption takes place, the pyroclast or the bigger materials is erupted out, clearing away this passage, and over here explosion takes place. So it forms like cone like structure. So the name cinder cone volcanic mountain. Okay, and lastly, what we have seen is the composite volcanic mountain formed because of the composite lava or the acidic lava, also known as stratovolcanic mountains. Okay, caldera are the one which is very dangerous, very explosive. So what happens is usually they explode themselves. They are so explosive that they may explode themselves. Okay, leading to the a total collapse of the structure. Volcanism have several effects, some at positive, some negative also. So most of them are negative. So so the negative effect or the destructive effect of the volcanism is it may cause the explosion may lead to the release of several gases. Okay, or it may cause burning also. It may cause tsunami. Okay, for example, in 2022 Tonga volcanic eruption led to the tsunami in the Pacific region. Then also it may in the recent year it was there in the news also. The volcanic eruption is also responsible for the fire or eating away majority of the the regions, okay, into the fire. Volcanism may also cause climate change. Okay, may also cause climate change. So for example, you can see over here in this case when the this is the volcanic ash cloud. Okay, so when the sunlight is not able to penetrate down, most of the sunlight is getting reflected back. Okay, so albedo effect increases and less amount of the sunlight will be reaching the surface, so it may cause cooling effect because majority of the sunlight is getting reflected from the upper region itself, so less of the sunlight will be there, so it will be causing cooling effect. Okay, so volcanism may cause cooling effect, but it may also cause a long-term negative impact. For example, volcanism, when it is releasing the sulfur dioxide, it is releasing nitrogen, so sulfuric acid or the nitric acid, okay, may be formed, or it may also, these are also the greenhouse gases, sulfur dioxide, nitrous oxide. So in the long run, it may increase the temperature. Okay, it may increase the temperature. So here in this case, acid rain can also happen because of the volcanism. Volcanism also have some positive effects. For example, new minerals comes out, okay, and those minerals at times may be very, very useful, very expensive also. And volcanism is also responsible for the heating effect. So in some region it will be responsible for giving rise to springs and geysers. For example, Puga Valley in Ladakh, Manikaran in Himachal Pradesh. So there are these volcanism, okay, the not the volcanic activity, not the volcanic mountain, these hot spring and geysers which is found. Okay, so they can also give rise to the formation of new rocks. Volcanism is very, very important. Okay, so here geysers and spring you can observe. Now volcanism or volcanic mountain is spread majority in the Pacific ring of the fire region. In the case of the India, we have only one volcanic mountain, that is the Barren Island. Some volcanism may trap inside, volcanic material may trap inside, and it will lead to formation of the different structures. Okay, so when it is dome shape, it is laccolith. Okay, when the dome shape is reversed, it is lapolith. Okay, so this is batholith, stock, dike, okay, sill or the sheet. There was one question related to this also. Okay, there was one question related to this dike also. And in the same question, UPSC had asked question related to the difference between the basaltic magma and the silicic magma. So I hope you know which magma will have more amount of silica, acidic, and basaltic is the basic. Okay, so a very simple question here. Okay, the effects of all of these upon that of the earth. So all of these forces are responsible for some dynamic changes on the surface of the earth. Now UPSC have asked one or two questions related to the running rivers, especially with respect to that of the landforms. You can expect questions. Okay, and in the case of river, UPSC have asked question on drainage system of India, especially mapping based question. Okay, so the rivers have different stages, in the upper stage, middle stage, lower stage, and in different stages it have got different potential energy, and accordingly it makes different landforms. Okay, so in the initial stage, very high speed, then moderate speed over here, then very less speed. It is very deep but narrow. It is relatively less deeper but more broader. Over here it is very shallow and it is much wider. So in different stages, different potential energy, and accordingly different landforms is being formed. Okay, you must be knowing the difference between the gorge, because all of these looks similar. Okay, so gorge is the one which is very deep, steep valley like structure. It may or may not have water flowing, it may or may not have river. Valleys are basically the one which have the rivers flowing in it. Canyons are the one where the horizontal erosion is more dominant than the vertical erosion. Okay, horizontal erosion is there, so because of that the valleys are very, very steep and they are very like parallel. Here it is V shape. Okay, here it will be more like H shape. Okay, and when the glacier causes this erosion of these valleys, so mainly it will be forming the U-shaped valley. Okay, so river erosion say V-shaped valley, glacier erosion say U-shaped valley. Rivers also causes this waterfall and the plunge pools. Okay, these plunge pool, the pebbles and all will be responsible for the formation of the potholes. When the river flow along the slope, and when these slopes is made up of different grade of the material, some slopey area would be eroded more as compared to the other one, so there will be bumpy ride of the river. This is known as a rapid. The rivers carry sediments along with itself, and these sediments get deposited. Because of that, the river is not able to follow a straight path, and because of that, river starts a sinuosity. Okay, and over a period of time, deposition at some place, erosion at some place will lead to more and more sinuosity, and this river will start this S-shaped movement known as meandering. And at times, this because of too much of sediments, some portion of the river may get cut down. Okay, and the process may continue. Now, this meanders may be like symmetrical, that is incised meander, or asymmetrical, that is ingrown meander. So you can see from here, this is the symmetrical one, okay, or entrenched meander. This is the ingrown meander, wherein one side is gentle slope and the another one is the steep slope. Delta is a landform formed in the mouth of the river. Okay, because of the depositions, because of these factors, when the coastline is broad enough, when the slope is gentle, when the rate of deposition is very, very high as compared to that of the rate of erosion by the sea action, when there is mangroves forest also, and when there is absence of any oceanic currents or very less tide. In the case of India, this was a prelims question. They had asked question related to match the column. So you can see the deltas are mainly formed on the east coast of India. West coast of India do not have delta. East coast of India have delta. Why? Because these factors are mainly prevalent in the east coast of India. Okay. Types of delta, they don't ask questions. Here is the question. West flowing rivers of Peninsula India have no delta. True? Yes, this is true. These rivers do not carry any alluvial sediment. This is false. Okay. They do carry, but the rate of the deposition is not much for the formation of delta. Underground water, which is mainly stored in the form of this rocks, which is interconnected to each other. These are the aquifers, which is very, very important. And when it is in this order, where in the formation of the well takes place, it is known as an artesian well. And here again, when the underground water comes out from the another side, this is known as the spring. Karst topography is the landform that is formed in those regions wherein the this material is mainly made up of limestone. So water and limestone will react and lead to the formation of this structure, which is like kind of eaten up structure. So here you can see this is the karst topography, wherein somewhere above would be the river, and the river will come in contact with this limestone. Water and limestone will react and will lead to the erosion inside, and it will lead to the formation of cave-like structure. Okay, when this limestone is like protruding from up, it is stalactite. When this limestone is protruding from below, it is stalagmite, and this pillar-like structure can also be formed. Okay, now what are the landforms formed by the glaciers? So glaciers have more erosive action. Okay, the V-shaped valley, which is formed because of the river, which is formed because river will do vertical downward erosion, so V-shaped valley will be formed. But glacier is not formed throughout the river. The glacier is only on the surface, so sideways erosion will be taken place. So sideways erosion, say over a period of time, it will lead to the formation of U-shaped valley. So glacier is responsible for converting a V-shaped valley into a U-shaped valley. Okay, now it also causes a formation of some valleys to remain up, so those are hanging valleys. When these when this glacial erosion is leading to the formation of the valleys, which is directly meeting up the sea, so this zone where the glacial river is meeting the sea is known as fjord. Okay, this glacial river directly meeting the sea, it is known as fjord. So this region is very picturesque and very high tourist attracting regions. Sarki or the Kori basins are the one which is again formed, it is like a depression kind, which is formed because of the erosion by the glaciers. Okay, these this eroded material get deposited in the form of this structure, small hill like structure known as drumlin, or it can be a continuous structure. This continuous structure may be called as the eskers. Okay, this continuous structure, eroded material by glacier. Okay, this is called as the eskers. Waves and the currents. Waves have a very strong potential energy, and that can erode the coastal area. Okay, this coastal area, when it gets eroded, okay, when it is like a small structure eroded, this is known as the sea caves. When it becomes big, and when there is like in and out passage, so this is known as arch. Okay, arch. And when it is like eroded in such a manner that as a base is eroded, the upper structure also collapses, leading to the complete detachment of one portion from the mainland. So this is known as stack. Stack over a period of time may get eroded, and it forms a smaller structure known as stump. There may be one more structure wherein the because of this erosion, because of the hitting of the water, this erosion may take place, and a hole may be formed wherein the water may come up like a fountain. So this is known as blowhole. Okay, so this is a erosional landforms formed by the action of sea waves. Those eroded material would be deposited somewhere, so those are depositional landforms. So these are mainly sands. These are mainly sand. They become fine over a period of time. So these can be sand spit or the sand bars or the tombolo. All of these are sand related structure. Wind also have got some potential, but tides or the waves have more potential. So the potential over here with respect to that of the erosion. So this is the basin which is formed because of this the wind carrying away the sand, leading to the formation of a basin known as a deflation basin. Okay, the wind action may also erode the base of the rocks, leading to the formation of mushroom rocks. Okay, ultimately the entire region may be eroded, leading to the remnants of the very hard rocks known as the Engelbergs. Okay, so even it may lead to the formation of the bolsons or the pediments. Now arid landforms is relatively important over here. As you can see, those regions wherein the aridity is very, very high, that is the rate of precipitation is less, evaporation is more. So those regions the rainfall is not much. Okay, so it is basically the wind action, or if there is some river actions. So the plateaus may be eroded, leading to the formation of smaller plateau known as mesa. This will be eroded to form a much smaller one known as butte, and this will be eroded to form a plain known as the penny plains, and some very hard which may not be eroded will be left over. Those are known as Inselberg. There can be some lakes also known as the oasis. Okay, or the salt pan known as playa. So oasis and playa, they both are lakes. Oasis and playa both are lake. Now with respect to the oasis, as you can see over here, okay, oasis you can see over here, when the erosion is taking place, a point may come that the wind have eroded the sand so much that the water from below is coming up. Leading to formation of lake known as oasis. So oasis is the lake where the water is coming from below. Okay, and playa is a lake wherein the water is from above. It can be because of rainfall. Okay, so playa basically there is no supply of water from below, so at times they dry up, leading to the formation of salt pans. Okay, oasis, water supply is there mainly from below. So oasis is relatively there for longer period of time. Okay, now some sand dunes of different structures may be formed, all because of direction of the wind. When the wind is coming from below and such sand dune is formed, it is known as barchans. Okay, when the wind is changing the direction, when the wind is not coming from here, instead of when it is going from here, so it will be arranged accordingly. It will be arranged in this manner. It is known as longitudinal sand dunes. Okay, when the sand is coming from below and it is forming a structure wherein the one side is gentle sloping, one side is steep sloping, it is known as transverse sand dune. And when the sand dune is formed along the coastal area where the sea breeze along with that of the vegetation is leading to the formation of this type of sand dune, it is known as the parabolic sand dunes. Okay, so here some important landforms we did, and just one liner was important. You are really not expected to go much into detail. Now this is just to make sure that you are not leaving anything. At the same time, you are not going too much into the detail of those topics wherein less probability of question is there. More question shall be asked from those aspects which is very dynamic, like for example climatology. So we'll just start with the climatology now.